All right. Hello. Thanks for joining me. Hello. Uh, Part 16. Um, Another busy week. Again, only my second stream this week. Um, but we're making good progress, I think. What we're making good progress on is a WebAssembly interpreter, which is written in Ruby. The reason why I'm writing a WebAssembly interpreter in Ruby is to have fun, to demystify, slightly mystify, but then demystify WebAssembly for myself, and just sort of work in the open, share how I do it for whatever that's worth. This is where I remind myself that I'm doing this to have fun more than to make a functional WebAssembly interpreter. It's okay if it doesn't execute all of WebAssembly as long as I enjoy myself. I want it to be sort of correct and principled, even if the performance suffers as a result of that. I want to prioritize clarity over cleverness. I want to do it all in pure Ruby. That's going okay so far, so I'm going to try and keep that up. I don't want to do it without any dependencies, which is also going okay so far, so I want to keep that up. Oh, hello, James. Hello, Chris. Wow. I'm I'm very glad that you're both joining me for some Friday night fun. I can definitely guarantee that this is going to be the most fun you could possibly have on a Friday night. So please sit back and relax, crack open a cold one, a nice cold can of red wine, and just relax and enjoy. Um, I've always got this bit at the beginning where there's a retro. I don't actually have very much to say this time. I sort of finished halfway through something last time because it became very late and I was very sleepy. So I don't have a huge amount to say. I'd like to just carry on with what I was doing last time and then maybe I'll have some thoughts about it. However, previously on this, we now have an abstract syntax parser, which is a big relief. That means that the evaluator now doesn't have to deal with the concrete syntax of expressions anymore, which is great. It doesn't need to know about the static arity of instructions. It can just deal with those structs that represent instructions rather than an unknowable quantity of atoms from the S expression. So all of that, very nice. I like it. Oh, James has got his presumably real tankard of beer out, so that's fantastic. I'm glad to hear that. I would like to expand the AST parser to cover modules, which includes function definitions and stuff like that, so that I'd like to get to the point where literally the only S expressions we have to touch are the ones relating to the reference interpreter test script format, that .wast format, that isn't really a WebAssembly code anyway, so I don't mind if we have to touch the sort of disgusting atoms of that S expression, as long as once we get into, here is a cromulent WebAssembly module containing function bodies, I want that to be abstract syntax. I kind of blasted through the implementation last time, to just sort of... What I wanted was to get everything in the expression evaluator cut over to the new approach, which I did get done, but only by just kind of, as usual, sort of charging at it, not really thinking about what the names of things should be or whether I've, organized things in the best possible way. So I'd like to take some time now to sort of clean up that code and see what improvements I can make before we bounce back to adding more language features and trying to make more of those tests pass. And, at that point, we'll sort of forget all about this parser. So at that point, it'll be too late to make it better, won't it? Let me make this go away. Yes. And then if I press this, great. Oh, seamless. Look at that. All right. So here's sort of where we got to last time. Let's just check that the tests are running. I believe that they are. Tragically, at the end of the last sesh, as I've decided to call them, the tests didn't run when I pushed up. And at the time I checked GitHub status and it was saying like, I don't know what you're talking about, mate. Everything's totally fine. I'm pretty sure. Yeah, I checked like, well, you can see when I checked. I checked, this was like maybe a couple of minutes after I turned the stream off. And sure enough, GitHub status had gone from being all green to being all yellow, which means nothing's working. I can't imagine what would happen for it to go red. But yeah, so I've got my GitHub repo is in this rather sad state where there's no green dot to be seen. I don't have my workflow set up to have the button that you can press to run it manually. So the main thing I want to get out of this session or sesh is to just push up some new commits so that the actions tab actually has a new workflow running it rather than this one that's from 7 days ago. That's absolutely terrible. Yeah, here's where we got to. So mostly this is stuff that I still had on my list last time. I did notice something here that I want to fix. But essentially I got to the point where we were successfully parsing all of the different kinds of instruction inside parse expression. But I do want to clean this up a little bit. I said here, as in S-expression parser, this holds on, well, so this does, I guess these are two slightly different concerns, but maybe I can think about both of them. When you instantiate S-expression parser and you call parse on it, it actually stores the input as part of the state of the parser so that it doesn't have to pass it around everywhere. So that's quite convenient. Like when you call parse expression, you don't give it an argument because the parser object holds on to the underlying string, and then it doesn't really mutate it, it replaces it, but effectively what it does is mutate the current string. Thanks, James. And the other thing it does, well, I guess I've said the other thing it does, which is that it mutates it. It doesn't really, it replaces it. But in this case, I think maybe we could make this parser, instead of always keeping track of what the rest of the S expression is, and here, like, you know, there are two gross things going on here. Firstly, the fact that I have to pass the S expression in when I presumably could just be holding that as part of the state of the parser rather than passing it in. And then secondly, the fact that I've got to pass the remaining S expression out when I could just be mutating the argument that gets passed in here. And I mean, in general, I don't really like mutating stuff if there's an alternative. But in this case, it feels like I could cut down on a lot of there's a lot of sort of boilerplate here that's just to do with shuffling values in and out and making sure that they get returned properly and stuff like that. And I think I would like to just sort of get rid of some of that ceremony. So that's something I want to look at this time. And the reason it's all here is because this all just got copied over from the evaluator. And in the evaluator, whatever the data structure is that I am evaluating, whether it's a concrete syntax S expression or an abstract syntax AST, I don't want to mutate it in the evaluator because I'm not confident that that's safe. But here, the S expression is the only function of the S expression is to be parsed into an AST, and then it's just going to be thrown away anyway. So I think it's okay to modify it. But yeah, I sort of copied all of this splat rest stuff over from the evaluator. So yeah, I want to destructively consume the S expression. And like I said, so that'll eliminate the need to thread rest through everything. I'll just be able to keep referring to the same object and mutate it rather than always splitting it into first and rest or whatever, which is mostly what I'm doing. And then I'd like to try and store the current S expression as state, so that basically what I want to get to is a place where I can just call parse numeric instruction, for example, or parse expression with no arguments, because it's just a sort of stateful operation on the parser that tells it to do whatever it does internally, advance a cursor or whatever. What it's actually going to do is just chomp its way through that underlying S expression. I'm not really sure whether I want to do these two things in this session. I could. I think it sort of depends on what my enthusiasm level is by the time we've done this refactoring. Because like I said, in the interpreter, there's this whole chunk of code at the top here, this script.each, which is just iterating over the top level S expression. And when it finds something like module, that's just a WebAssembly. That's just a bit of WebAssembly. And at the moment, this doesn't go through the... I didn't extract that into the AST parser. I only extracted the expression parsing stuff, not the module parsing stuff. So you can see here inside the module, there can be a function definition. There can be one of these memory commands. There can be this sort of type, table, and global, which we don't know how to deal with yet. So I'm just skipping them. I mean, stuff here, invoke and assert return, those are just parts of the test script. So I'm quite happy to just leave them as they are, even though they're a bit messy. But I'd sort of like to be able to move this chunk over. This is basically what I did last time, move the contents of evaluate expression into the AST parser and make it parse expression. Here, this is effectively evaluate module, and I'd like it to become parse module. But that's probably going to be a little bit tedious, if you can imagine such a thing. So I might not do that right away. I might save that as a treat for a future time. And then this, actually look up indexes in an identifier context. So I skimped on a lot of the detail here where, where's a good example? Oh yeah, this. So all of these, local.get, local.set, local.t, branch if, and call, all take this sort of index argument that refers to an identifier that's already, one way or another, that's already been defined in the enclosing and sort of lexically enclosing scope. And what the AST parser is supposed to do, according to the spec, is look up that identifier and replace it with a number. So for example, for local.get, you can just refer to local variable number 3, and that should just pass through unchanged. But if you refer to local variable $foo, what we should be doing here is replacing that with a number that represents what the index of local variable foo is in the current scope. And at the moment, I'm not keeping track of that. I'm not building this identifier context. And so there's nowhere for me to look foo up at this point. So at some stage, I'm going to have to deal with that. So I've left that on this to-do list. Again, I suppose it's not that bad, but it just feels a little bit like, do I have enough brain juice on a Friday evening to think about that? I'm not sure. So anyway, that's what I want to do. Those last two are kind of, stretch goals. So I'm not going to beat myself up if I can't be bothered to do those. Because it'd be nice to just make some more tests pass, like that's the main goal here, is to make tests pass. This is all just sort of refactoring, basically. This is definitely a stretch goal. I don't even know if I want to do that. I don't think I can be bothered to even think about that, so I'm just going to put won't fix. I wrote that down because it came up last time, but I think that's too boring to even contemplate. Decide on a systematic approach to S expression abbreviations. Yeah, that's kind of a stretch goal. At the moment, I'm having to deal with the fact that, well, I guess I'm actually doing this in unfolding right now. So for example, the fact that the else clause is optional in an if, it's sort of writing an if without an else clause is kind of an abbreviation for an if with an else clause. And right now I'm handling that sort of ad hoc here, but in the specification, there are lots of these abbreviations, particularly at the module level, there are some of those abbreviations. And so maybe I need a sort of another phase that maybe comes, I don't know if it's before or after the expression unfolding, that actually sort of expands those abbreviations so that by the time we get down to the nuts and bolts of parsing, it's sort of been normalized, and I just have to parse the sort of canonical representation, and I don't have to worry about dealing with abbreviations. And that's currently the case, but only because I'm doing this sort of ad hoc abbreviation expanding for if, and I think maybe that's the only one I'm dealing with right now. So yeah, not sure about that. Extract parse instruction, CF evaluate instruction. Well, why don't I do that to get started? Because that sounds very simple. That sounds like just moving code somewhere. I think that's referring to this chunk of code. This whole thing that, this whole chunk of code that just gets shoveled onto the end of result is a huge indented case expression. So I think maybe it would be good if I did def parse instruction. I'm not immediately sure what the arguments to that are. It sort of looks like it takes an instruction. Yeah, so the instructions kind of come out of the S expression already. So let's just make that parse instruction, which kind of makes sense. Oh, I bet this is going to have to return rest, isn't it? Yeah, see, again, I can't just shovel this on the end. I have to do some admin and say what we get back is an instruction and the rest, and then I can shovel the instruction on the end, and then I have to update the S expression for the next time round the loop. So that's exactly the sort of admin nonsense that I would like to get rid of ideally. Oh, hold on. So this actually takes the S expression. Hold on, let me just do the rest because I forgot. I'm going to forget about that. Instruction rest. Oh, let's call this. I'll call this result for now. Oh yeah, this is a bit of a dog's dinner. Maybe I should have done this in a different order. Hold on. Part of my motivation for doing this was to avoid that horrible indented thing, and I'm just re-indenting it again. So I'm gonna do tap here, and then I can return result and rest. So again, not tap then. So I'm going to return the result and the rest. So at the very least, I've outdented this big chunk of code and made it like a top level method body, but it's not quite that simple because this isn't going to work because, well, really this is the pain. This parse numeric instruction needs access to the whole S expression, not just this first thing. And I mean, I guess, like I said, I want to get to a point where I can just call something like parse instruction and it just uses the underlying S expression that I've stored on the state of the parser. And actually, I suppose it's sort of wrong for this to be taking instruction as an argument. What I really want is for this to take S expression as an argument. And then if I need God, I guess what I'm going to have to do here is say S expression goes into instruction and rest just to establish the precondition for this code, which is that either I mean, yeah, this really needs cleaning up, but I think the steps that I'd suggested are going to clean this up. But either we need the complete S expression, which is consumed, which is used by parse numeric instruction, and then that returns its own rest here, or we're just looking at the instruction, in which case, you know, this rest is the relevant one, and then some of these actually use that, you know, like that. So one way or the other, we get rest assigned the right value, which is what we need for it to be returned out the bottom here, and then it gets assigned up here. So like I said, all that threading through is really very unpleasant, but hopefully we're going to be able to do something about that. I mean, this isn't wrong, but it's sort of pointless. I think maybe this now, what I'm saying is I don't need to do this pattern match because I'm just passing the S expression in and then I'm going to get the instruction back. In fact, even the name instruction there is a bit misleading because it's just the first atom in the S expression. So I need to do some, clean up my naming, call elements of S expression atoms. Instructions are now the instances of the AST classes. Yeah. Okay, so that's another thing that I could do. But anyway, the point is, this is now, I think I can just do until S expression is empty, because that's effectively what this condition was doing. It's just it was also binding these local variables, which now I don't need because the relevant pattern match happens inside there. So this is just establishing a precondition that we don't call parse instruction when there aren't any instructions in the S expression. So that was rather a lot of nonsense. Does it work? Looking hopeful. All right. Pending test failed successfully. Oh, goodness. Ignore all space, please. Yeah. That's not too bad, is it? I haven't really changed very much. I've just changed the nature of that loop in order to support what we're doing inside. Basically, to make it so that the only data that parse instruction is using is the full remaining S expression, and then it pulls the instruction out itself. But I think that makes sense. So what is this? Extract parse instruction. I don't think there's anything interesting to say about that, so I won't even try. Did I actually rename it to evaluate instruction on this side? Oh yeah, apparently I did. Great. Well, okay then. So, all right. Can I clean up? I think maybe if I clean up my naming now, it will help me later. So basically, I think a lot of these occurrences of instruction are now like, that's good because this really is an instruction. That's what you get when you call parse instruction, you get an instruction back, but then it's confusing that inside here, it says we get an instruction from the S expression, which we definitely don't. We get, well, by the time we get down here, we've gone through unfold. So actually, this is definitely just going to be an atom. I was just thinking it could be an atom or an array. It could be like a string, basically, in the S expression, or it could be an array. But I don't think it can be because unfolding has flattened everything down into a flat list of instructions. So it must be an atom. So I'm going to, at least inside here, let's try replacing the word instruction with the word atom. Lazy atom. Can I not? That's surprising. Okay, I'll just do it. Oh, maybe it was just the G that was, yes, okay. Okay, so let's pull an atom out of the S expression and say case atom fetch. Okay, hold on. I think I can do better than this because atom is a bit too generic a term. It is an atom that we're pulling off here, but we only call parse instruction when the very next thing in the S expression we are expecting to be one of these like instruction types, which sometimes is a full instruction like return. Like that's why this is called instruction, is because sometimes it's like return, but other times it's, well, I mean, it's always one of these strings, local.get, local.set, blah, 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 drop. But then the other things that we get out of the S expression aren't necessarily instruction names. They're like static arguments. So like the index for local.get or whatever. So I think I want to call this like instruction name, or I'm just trying to think what this is usually called. Maybe opcode. I think I said that last time. I think last time I was talking about like opcodes. Maybe it makes sense to think about this because in the spec, WebAssembly core, maybe it's inside structure, numeric instructions. So it sort of refers to these as operations. Numeric instructions provide basic operations. And I mean, I guess maybe there it's referring to like I don't know. It's not specific about what it's referring to there, but like there is the word operation, and it talks about some syntactic categories here like unary op, binary op. So I think maybe referring to one of these as like the code for a particular op is probably quite good. So it's certainly better than instruction. So let's see. So I think that more strongly implies what this is actually going to be. That we're expecting that to be an opcode, and then we push it through this big chunk of code. Yeah, I think those are all valid. Really, that this thing here is not the numeric instruction regular expression. It's the numeric opcode regular expression. So opcode. Where else do I have instruction? Oh yeah, well look, it's all over the place in here. So let's try that again. Yeah, that's an opcode, 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 opcode. Yep, 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 yep. Not those ones. Those ones. Yeah, opcode.match, numeric opcode. Yes, that's an opcode. Yes, yes, yes. And then here, instructions. I think that should probably be like atoms, because it's not just opcodes. Okay, so where do we have instruction? So here, this instructions. Well, this is talking about the body of the block or the loop, because I know that in the conditional here, we talk about consequent and alternative. So really up here, it should just be body. So that's something to change in a separate commit. Here, that really is an instruction, so that's okay. That really is an instruction, so that's okay. I'm not sure about that in that name, but I can worry about that later because it's just a method name. But then here, yeah, that local variable I think should be atoms. Back at the top. Okay, all right. Well, so that... Okay, I just remembered that if I suspend Vim, it has a tendency to freeze. So I think I'm gonna do what I did last time and have a dedicated tab just for running the tests in, and then while the test's running, I can be faffing about writing a commit message. So this is, yeah, refer, say opcode, not instruction, when referring to instruction, when referring to atoms containing instruction names. Yes. They're not instructions at all. Oh, interesting. Okay, so Chris says the WebAssembly spec uses opcode to refer to the number that represents the operation in the binary format. Okay, well, I suppose there are two ways to take that. One of them is that I shouldn't do that. Yes, instructions are encoded by opcodes. Yeah, Chris, I'm just thinking about like, yeah, I mean, I think right now, right, I'm not implementing this yet, so for now, it doesn't matter, right? But this is really interesting. What I was going to say was, I suppose this could go either way. Either you could say, well, you shouldn't use that term unless you're referring to what the spec calls an opcode. But another way to take it, which I think is the way that I'm going to take it, which is that this is like the closest word that we have to refer to that concept, that like this opcode here corresponds to, well, not directly actually. You can see there's two for conditionals here because one of them is the if with no else and the other one is if with an else. But more or less, I think opcode is probably the closest thing we have. So, all right, well, that's great because, well, it's not bad news because that doesn't worry me enough to stop me from using that word right now. But I'm glad I know about it and I can put it in this commit. They're not instructions at all. They're raw strings from the S expression. And instructions are what we emit from the AST parser. Let's put this link in. Zeta notes that the WebAssembly spec uses the word opcode to refer to the, I guess it's just a byte, the byte which identifies each instruction in the binary, what's it call it, format. So it's not quite the right word to use here. At best, it's overloading a word which already has another official meaning. But it's better than the actively misleading instruction. So I'm going to go with it for now. Hopefully, I'll think of an even better word later. All right, and I said I wanted to make this body. Call the block loop body in unfold. That's not worth saying anything about. Let me just, yeah, I'll keep this running. What else was I upset about? Oh yeah, this. Okay, so let's just make this atoms. Yes. What did I say? Say atoms, not instructions, in, what is it? Consume structured. Structured instruction. These aren't instructions, but they aren't just opcodes either. They're a mixture of opcodes and operands from the S expression. But the S expression has already been unfolded by this point, so they should all be atoms. Okay. All right, so I know that was a bit boring because I'm just renaming stuff, but I think that's helping me to, because otherwise it's really hard to keep track of like what, you know, in the absence of a type system, I'm really quite dependent on the names of these things to retain my grip on reality. So I'm going to check that off. I'm going to say I've done that. All right, let's get back into the meat of it down here. Okay, remove else fall through from parse expression switch. Yeah, so this made me realize that at the bottom of this case, so this, what is now a switch on opcode, at the bottom there's just this sort of generic fall through that says, oh, if you don't recognize it, then that's fine. Just let it pass through unmodified. And I think I had that in there as a shim for when I was doing the cutover, you know, like when I was only translating half of these opcodes into instructions, into abstract syntax, I was letting the unsupported half like trickle through this gap in my conditional. But now I think as part of, you know, wrapping up at the end of last time, I probably should have deleted this, because this is, if I start reading a program that contains an opcode that the AST parser doesn't recognize, I don't want it to just leak through as an S expression. I want to get an exception here, which will force me to come and implement parsing for it. So I'm going to do that, and hopefully nothing has actually leaked through. And I can just, so what is this? Remove, else fall through from parse expression switch. I guess it's in parse instruction now. Okay. Oh. Interesting. All right. Well, I can't, that commit was premature. So in this float expras, which is rapidly becoming my, oh, I don't like this sidebar dingus, rapidly becoming my nemesis. Oh no, they've made GitHub better. Oh no. Yes, so here there is an unreachable instruction, which I think is supposed to just, what does it do? Control instructions? I think the idea is it's a failure. Yeah, unreachable trap. So I think that means like throw an exception, essentially. So this is like an assertion that you can put in your program to say like, this should never happen. So far it's not a problem that I haven't explicitly implemented this, because actually if we ever find this, it will cause an exception because the interpreter doesn't know how to execute it. So in a way, I have implemented it. But clearly now, even though we don't have to execute it, we are going to have to be able to parse it. So let's back out of that. And I'm doing stuff all over the place here. And implement that. I'm not really sure what order I was doing these in. I seem to have like stacked everything up above this block loop if, I guess because it's quite large. Maybe I should extract this. And I've also just realized that this is unnecessarily matching into the opcode. So okay, one annoying thing at a time. So I think I'm gonna try and break that streak of like stacking everything up above this, because there's nothing special about block loop and if. It was just that they all happen to be they'll happen to be together in that with that big block of code. So let's call this in unreachable unreachable.new, and then I'll just have to put that in the AST. Hopefully that fixes that. So it was just float expras. Let's just rerun that. Yeah, so it never tries to execute it, which is what we want. So did I have some kind of yeah, parse unreachable instruction. We can't actually evaluate this yet, but since its only job is to raise an exception, that's not much of a problem. And now am I just yeah, it was head 4. Okay. And yes, quite right. So we've got that back. And now, hopefully, yes, that's all good. Okay. Right, so a couple of things. I noticed that this is unnecessary. So this is remove unnecessary reassignment of opcode in parse instruction. And that was very bold of me, but I'm almost certain that that's not doing anything. Yeah. And then maybe I will just extract this, just in the interest of keeping the method kind of manageable. No, because that's gonna. The problem is this is gonna suffer from the same problem as that extracted. Oh, I mean, I could just promote it up there as this parse numeric instruction. Like, okay, yeah, let's just do it. Let's just do it. You know, this needs to be something like parse structured instruction. And it needs the whole S expression. So again, unlike all of these other ones that are, I suppose it's okay if it lives down here. There's no need for it to sit at the top there. It's just that it needs to return structured instruction and rest. And then it needs to return structured instruction. So we've got parse numeric instruction. Oops, I didn't mean to paste that, but whatever. Def parse structured instruction S expression, and then all of that becomes the body. Okay, what exactly is going on with this method? Yes, so just like parse numeric instruction, I have to reproduce this nonsense at the top to say, well, before you can do anything, you've got to pull out the opcode and then the rest, and then all of this deals with the opcode and the rest. Oh, and then we need to do this then. Oh, what a mess. What did I call that? Result. So this is just result. Result rest. Okay, I think that's probably okay. Yes, I'm going to use that as my float expr as my fairly... Oh no, why did I do that? Don't do that. Okay, don't load it, because I didn't mean to reset it like that. Okay, good, I've still got it. I should just keep this. I shouldn't be doing git reset hard in the, well, anyway, really, but certainly not in the tab that I'm running my tests in. Ignore all space. Oh, well, that's useless. So let's say extract parse structured instruction. Okay. I think that... I was going to say that answers your question, James, about why I don't use the editor, is so that I can, if it fails, I can just use my shell history to retry it. But I suppose if I don't know if it would have opened the editor actually, because I'd forgotten to add that. I'd forgotten to stage that change, so I'm not sure what would have happened there. Maybe that's nonsense. Okay, is there any more? I thought of something else that I should be doing here. Oh yeah, I realized that these are all nullary instructions. So I think what I'm going to do... Oh, and unreachable. Yeah, it was adding unreachable that made me remember that we've got this big chunk of nullary instructions here that could all just be handled together. Select, nop, drop, unreachable. And we could just do a variant of this. I mean, obviously these lookup tables need to go somewhere, because it's rather silly that I'm listing out the keys of this hash only to then reproduce the hash in line. This should just be a match against the keys of this hash. But so this is just going to be fetch opcode new. So this is going to be return becomes return, select becomes select. Obviously I could be using some sort of Rails style convention over configuration situation here, but I'm going to try and keep things explicit as far as possible. So I think all of those can be coalesced into that. Does that work? Oh, let's do it here. Yes, pending test failed successfully. So what would this be? This is just yeah, combined parsing of nullary instructions. And yes, that has not caused any new failures. So this is becoming a little bit more organized now. I'm going to resist temptation to faff with this anymore, because this is I'm sort of going off on a tangent from what I was intending to do. What I was intending to do was remove else, and I have done that, and that just sort of provoked me into realizing that there was some other cleanup to do here. But clearly there's more stuff. I could extract these hashes into constants, and also this here really is just like parse index. That should be its own method, but I'll stop before everyone closes YouTube in disgust if you have not already done so. Okay, this is the semi-interesting bit. Refactor AST parser to destructively consume the S expression. So what that means is everywhere that I am currently... Oops. Everywhere that I am currently... Well, where's the best place to start? I don't know. But like right now, yeah, I think actually I do know where I want to start. I want to start at the leaves, because I was thinking like there's actually a sort of a tree now. There's parse expression at the top. That does a bunch of threading with rest. And then that calls parse instruction, which can call parse numeric instruction and parse structured instruction. So I think what I want to do is to start with these ones that are at the bottom of the tree and look for places like this Well, basically, where are the places that rest gets mentioned? There, there, there. That's okay, that's just returning it. And rather than have it, I mean, basically what I want to do is eliminate rest inside this function. So what I mean is, instead of just matching S expression against the first element and the rest, instead what I want to do is essentially S expression dot shift just goes into opcode. So I'm sort of moving rest onto the other side of the equals sign here almost, and saying like, make the left hand side end up being rest, and then just let opcode be the first element of that. So here this becomes, instead of rest into, it becomes S expression dot shift again into string. This becomes if S expression, oh, it's so far down, I should just type S underscore, shouldn't I? If S expression in, well, yeah, I mean, maybe this isn't quite as good, because I need to do this test to find out whether I even want to go into the conditional, right? So like, in fact here, I what was this originally? Sorry. If rest in array, right. Okay, let me just think about what I want this to become. Well, rest is just S expression now. I've not learned my lesson there. If S expression in blah, but then I don't want to assign rest here. I just want to check. So I mean, I could do this. I could say if S expression in this, an array beginning with this, but then that's just the same as saying the first thing in S expression is that, if it's in that. But then the problem is, if it is, then I need to do S expression dot shift to get it off. And I think probably this assignment here, it should be S expression dot shift that's getting. I mean, this is a little bit funny, but maybe this is okay. Like, essentially what this is doing is saying match S expression, match the first entry of S expression against this regular expression. And then when that succeeds, bind the value of it to this offset variable. So I would take offset away up here. And then this, so this thing in the middle isn't really doing anything, but in a way, this is just like an assertion about, as this value travels into this local variable, it's sort of being squeezed through this, like plasticine being squeezed through a, no, it's not like that. It's like a key fitting into a lock, right? It's like, the thing that's being shifted off the front of S expression has to be of this form in order to make it into this local variable. And actually, given that I've already written this, I think that's kind of nice. I don't know if there's some kind of pattern here that I should be taking advantage of, but for now, I'm quite happy for it to just, oh, I just realized this window's perilously close to the, since I opened a tab, it's become perilously tall. Sorry about that. So yeah, I think I quite like that. Is that the end of rest? Yeah, you're right, Chris. The if will guard it. So it's not really necessary. I think I just kept it in there because I sort of like the look of it. It's not doing anything. It's not doing anything. Maybe I should take it out. But like I was saying, I just don't know if there's some pattern that wraps up these two lines of code like nicely. Maybe there is. I mean, I'll be honest, part of the reason why I'm leaving this in here. Oh, actually, maybe I can take advantage. Actually, because I can. Oh no, I was thinking I could use that. I was thinking I could use that refinement I've got on match data to just match this against a hash pattern, but I can't because there's no match data here. I'm just going to leave it there for now, and then I'll come back. I'll come back and think about what to do with that. But yeah, it's at the moment it's just sort of documentation rather than this pattern match can never fail because of this if, as you quite rightly say. Anyway, I was looking for this. So now this should be S expression. So I guess what I'm saying is I've now got this method to the point where there's no need for it to return, because what it's doing here is just returning the same object that got passed in as its argument, but it's mutating it. So rather than returning something else, it's actually just changing its argument into that result value. So I'm hoping, firstly, that won't break anything, and secondly, that if I make that change universally without breaking anything, then I'll be able to do like a single global change, which is just get rid of all of those. Everywhere I've got rest being threaded through, just throw it away everywhere, and it will just be a single S expression object that's passing into all of these methods and being mutated by them, and I get to lose that. Hopefully I won't have to say rest anywhere. So I'll write a commit message while this is. So I'll say destructively consume I suppose S expression. Yeah, that all seems fine. Well, let's just do it in human words. S expression in parse instruction. I'm trying to work towards a point where nobody cares about the rest return value anymore, so I can just remove it everywhere. This is the first step because parse instruction is at the bottom of the call graph for parse expression. Sorry, it's parse numeric instruction. Yeah, that's right. I was confused by the diff. This diff header here is telling me information about the very first line of the diff rather than information about the first line that's changed in the diff. So yes, that end does belong to parse instruction, but that's actually not the method that I've changed. So that's slightly annoying. I was uncritically trusting this diff header, but I should not have done. Numeric. Oh, poo. Oh. Okay. Yeah, I'm really not sure about this. Let me finish this. I'm going to make a note. Goodness, there's so much stuff in here now. Get rid of the match. Assign local through pattern if it's not pulling its weight. Weird. Wait. I'll just put an example here. E.g. if it's not pulling its weight. So this is all. I wish Notes would let you do stuff in monospace, but you can't. If you want that to be in monospace, you have to make the whole list item in monospace, which is basically never what you want. Thanks, Tim Apple. Okay, so let's do that again. That was exciting and successful. So again, that. Yeah. Oh, look, this one isn't at the bottom of the call stack because it calls consume structured instruction. So let's take a look at this one. This. Goodness, how is this going to work? Okay, so let's just get rid of that. This is, I want this to return S expression. So this is until S expression in hat terminated by star. I mean, again, look, this is what this is really saying is until S expression first in, well, I mean, of course, this is a slightly perverse way of doing it, but, well, I won't change that. I'll just leave it like that, but I don't think this pattern match is really pulling its weight there. So case S expression. Well, look, both branches of this just need the opcode. So I'm going to change this to be case opcode and shift that out of the S expression. So we shift it out each time around this loop, we mutate the S expression, and then this just becomes that, and this just becomes that. Consume structured instruction, we pass in the S expression here. Oh, how does this work? So this is stripping the terminator off of the front of the remaining this thing here is different, isn't it? What is this? Foo. That local variable was shadowing, I think. Yeah, it was shadowing the argument, and it was just because we weren't actually using that argument inside the body here. But now that we are, that's become problematic. So I need to give this some other name, which I don't know. I mean, essentially, the second argument here is the S expression, and then we need to pop the terminator off the end of it. So I think that needs to become S expression dot shift. If I was going to continue with my reign of terror, it would look like this. Like, essentially, this pattern match has moved down there. And then this whole thing here just becomes S expression unnecessarily, because that'll be the same object as we passed in now, because of the change I've made down here. I mean, this is a bit of a mind bender because this is a recursive function, but I think if our sort of induction hypothesis is that this method is going to mutate its first argument, then we don't really need to get this back, but we will. We strip the end off of it, and then this just becomes opcode foo terminator. I think I'm just going to call this body. What I really want to call it is atoms, but that's already the name of this. I'm going to change that. result. No, okay, I'll call it body. I don't want to change more than is necessary here. The thing is, this is slightly misleading because if doesn't have a body. That's why I was sort of resistant to that, but whatever. So I think maybe I think maybe that's okay. Nothing too broken yet. So what did I say here? Destructively consume S expression in consume structured instruction, which does say it's going to consume. Yeah, I'm just going to leave that alone for now. I don't really like the naming inside there, and also I can see that this could be tidied up a bit. I'm sure I'll be back. For more tidying up. There's plenty of other stuff to be, plenty of other nits to pick there, but let's stay focused. So now that I've done that, now I can reasonably approach this, because this is a bit of a, there are a lot of calls to consume structured instruction here. So this is going to be sExpression.shift goes into opcode. This is that similar deal again, where it's like if the first S expression matches that regular expression, I've just realized that I could have done the thing that I wanted to do. I'll finish this first and then I'll go back to that. So this is now going to become sExpression.shift. Push that through the pattern and into label. So same deal again, same pointlessness. So what's this? So this is conditionally shifting the type off the front of the S expression. So this needs to become if S expression dot first in that, then S expression dot shift. And we're not actually storing that anywhere. Yeah, we're just throwing it away. Okay. So this is going to become S expression, obviously. All of these are. That also becomes S expression. So what do we do with these result values here? I think it's the same deal, isn't it? Instead of doing this, I need to do S expression shift is pushed into end. That's what this is doing. It's forcing us to trim the beginning off and also asserting that it is end. So that just becomes S expression. I think it's going to be the same for all of these. I need this. Okay. So in this case, it's going to be else. This one is going to be end. Like, this makes me realize that when I introduced this consume structured instruction, oh no, actually after I introduced it, I made a decision based on aesthetics. It was about symmetry, that because consume structured instruction can't expect the very first atom to be the if or block or loop, precisely because we want it to support else. that it was not gonna, we call it after we've already consumed the block or loop or if atom, and then it returns before it reads the end or the else, like the terminator at the end. But actually, what this is showing me is that every time we call consume structured instruction, we then have to throw away the terminator because we definitely don't want it. Even inside consume structured instruction, we have to do that. So that now feels like it was the wrong decision, because this clearly needs to just be built into what consume structured instruction does. If it's something that you have to do every single time you call that method, then really it should just be part of that method, right? It's part of the functionality of this method has accidentally sort of plopped out to the call site, and that's not what we want. So this becomes S expression. This becomes S expression. Let's see if we've broken anything. On the assumption that we haven't, let's say destructively consume S expression in parse structured instruction. That was a preemptive commit. All right. Looking good. All right. So, how close are we to being restless? Oh, unfold is different. I'm not gonna complain about that yet. Maybe parse instruction? Yeah, we've done all of the downstream. We've done all the callees of parse instruction, so now we can do parse instruction. So this is all the same mechanical transformation. So this is S expression.shift goes into opcode. This here, this just becomes S expression, pointlessly. This becomes S expression.shift goes into index, I believe. This becomes S expression pointlessly, and then this becomes S expression. So that was pretty easy. Oh, I broke it. 122. What did I do wrong? Nil. Okay, hold on. What did I change? Oh, poo. Okay, that makes sense. So the problem is that previously this code only worked because this line left S expression alone. So this gave us the opcode and it assigned rest, but it didn't change S expression, but now it does. So parse numeric instruction is expecting to get the original S expression because parse numeric instruction itself does the shift the opcode off the beginning of the expression, which I think is the right way for it to work. I think all of these parse functions, you should only call them when you know that you need, this is how recursive descent parsers work, right? Like you only call this is essentially like corresponding to a non-terminal in the grammar. Like I know that I'm about to read a structured instruction, so please do it for me. And the first part of parsing a structured instruction is reading the opcode, right? So that's, in all of these cases, the first part of parsing a numeric instruction is reading the opcode of that instruction. So that part feels correct. But we've got a problem here, which is that I sort of unconditionally remove the opcode from the S expression because all of this needs it, or rather, to avoid repeating that all the way down here. But this very first case, I need to reach this without doing that. So I guess what I'm going to need to do here is shift this around a little bit. This needs to be like in an else clause. Like that. Again, we've all gone a bit indenty. Oh, I've gone way too indenty. That was far too far. So hold on, what am I doing? It's that much, I think. I think that's right. And then this. Yes. So, in fact, this can just be if opcode in numeric opcode, then parse numeric instruction, else shift the opcode off the S expression, and then this becomes case opcode, which is what it used to be. Yes, okay. Oh, but here we don't have the opcode, so this has to be S expression first. So we're sort of peaking. In fact, maybe I should have a helper that does this. I'm sort of peeking at the S expression to decide whether to consume it as a numeric instruction, and if not, then potentially there's another method to be extracted. This is another parse method, right? This is like parse non-numeric instruction or something, which again begins with that S expression dot shift. Okay, I'm fairly confident this is going to work now because I think that was the problem. While that's going, so this is more or less the same thing. Destructively consume S expression in parse instruction. This was slightly messier because we need to preserve the original S expression if we're calling parse numeric instruction. Oh yeah, Chris says if you prefer the peak next terminology, you could call to enum. Yeah, that's a really good point. I hadn't really thought about that yet. Well, the thing is, Chris, that this S expression that we get back is actually already an enum, because when I did this thing to make the S expression parser incremental, this is S expression parser.parse does return an enum. So I could, well, is it enums all the way down? No, this returns an array. I could make it so that it's enums all the way down, and then I could literally just do what you're saying. Like I could always just call next and peak to have a look at the next atom. Yeah, I'm going to think about that. Let me push that onto my stack of doom. Take advantage of the fact that S expression is, at least at the top level, already an enumerator, so we can call peak and next on it directly instead of, e.g., S expression first, S expression shift. That's basically, I'm attributing that to you, Chris. That's verbatim what your comment said. I mean, what you were actually saying was that regardless, I could just call to enum on it, and then I can take advantage of that. Yeah, I'm going to park it in that. I'm going to, I suppose I'll put here, or alternatively, just call to enum on it first so that I can use those methods regardless of whether it was already an enumerator or not. But yeah, that's a really good idea. Thank you. What was I doing? I was writing a commit message. Destructively consume S expression. This was slightly messier because you need to preserve the original expression if we're causing parse numeric instruction. But that's easy enough to do by just moving the S expression dot shift slightly later in the method. Okay. What other resty bits do I have? Oh, that's in unfold. So it's just here. So now, perhaps, the magic is going to happen. The magic being that I think all of these places where I'm returning an array like this, I don't need to return an array because this value I'm getting back is just the one I passed in, so it's completely pointless. So I think in all of these places I can get rid of returning the 2-element array. So that one's just returning result. Hopefully that's what this is being assigned. Yeah, look, so I can outdent this whole business and just literally return whatever that case returns. Yeah, the places where I had the presence of mind to use then, I don't have that outdenting to do. This is just atoms. So, oh man, the problem is now I've got to find all the call sites of those. Okay, well let's just look for this telltale situation. There we go. So this is just instruction equals parse instruction. Like this is what I wanted to get to, right? Is a place where, well, in fact, look, I can just inline this. I don't even need to name that local, and I don't need to do this anymore. So this is now much nicer. Again, you can see it would be so nice if this was an enumerator, because then I would just be yielding parse instruction here and I wouldn't need to accumulate stuff into an array, but that's return an enumerator from parse expression. You know, that would be really nice. Like now this has become very simple. This is what I was hoping would happen, is that once you take away that administrative overhead of having to move multiple return values around to the right places, it suddenly becomes a lot neater. There's probably something about monads in there, but I'm not going to get into it. Well, this hasn't matched my search, but I can see that it is an arrow into a... I mean, is there any way for me to write that? Can I say new lines or spaces, star? No, I don't know what I'm doing. Okay, whatever. I don't understand what weird syntax Vim supports in its search patterns. But anyway, maybe the best thing to do is just find all of the... Where are all the places that I'm calling parse instruction? Only there. So I fixed up the call site. Now, parse numeric instruction, all of those call sites need fixing up. So here... Well, look, again, it's only... You know, it's basically this, but we're just returning it, so I don't even need to assign it. I can just get rid of that parse numeric instruction. That's the only call site. So that extraction was just decomposing this larger method. I think most of these methods are just decomposed from, you know, to avoid having a parse expression method that's 10 pages long, basically. Okay, so that's all the callers of parse numeric instruction. So what about parse structured instruction? Yes, here we go. Same deal again. Look, it's just this just wants to return the first value in that array, and if we don't need to reassign S expression anymore, then it just becomes that. Okay, that was it. Again, that's the only call site. Parse numeric. Have we already done that? Yeah, we did that already. So parse numeric, parse structured. Consume structured, obviously. So now that just becomes body equals. Body equals. consequent equals alternative equals. See, these all get pushed through parse expression, and I could do that inline, but I think I will inline that, but I'll do it in a separate commit. Oh, and of course there's a recursive call to consume structured instruction here, so we've got to be a little bit careful here. But this is just body equals that, so that's actually pretty easy. I think that's it. If I missed anything? Remember in the old days you used to have to think about whether you'd missed anything. Don't do that anymore, just run the tests. Okay, I think that's convincing. Convincing enough for me to make a commit. So, yeah, it's a shame I didn't use then everywhere because it's generated a lot of noise in the diff with respect to outdenting all that code, but I think that's a lesson for the future, actually. Whenever I want this kind of thing, I think I should always use then. It's purely to avoid the entire R value here. Well, the entire right-hand side of the assignment is what I mean. From being indented, because it doesn't play very nicely with get. So, okay. So this is remove unnecessary S expression return values. So I'm going to say now that all of the parse methods mutate their S expression argument, there's no need to return a value containing the rest of the unconsumed S expression. So we can remove it everywhere and get rid of some of the administrative overhead of threading that argument through. Okay, great. So this was one of my to-do list items, wasn't it? Yeah, stop threading rest through everything. I think I've basically got rid of rest now, apart from in unfold where it's being used, I think, more legitimately. Oh, no, I don't want to see whatever you're... Okay, sorry, spam in the chat. So let's just see. I mean, I don't think there are any more rests. Oh, that doesn't count. Nearest. Okay, that's good. So I did say that I think there's a design problem with consume structured instruction, which is that we've got this overhead of having to do this annoying like every time we call consume structured instruction, and here, even the recursive call, we're having to manually remove the terminator, and that seems, that's a decision I made deliberately because I thought it was nicely symmetrical, but that's not a good enough reason given that it's just causing all this pain. So I'm just going to lose that. And from here, and then at the end, I'm just going to say S expression dot shift into terminated by. In fact, yeah, let me do that as like an atomic change, and then I think I should just change the way this loop works, because at the moment I'm sort of slightly bending over backwards to not shift the opcode here, but the only reason I'm doing that is so that it's left in the S expression when we return. But if I'm going to remove it anyway, then I should just take advantage of the fact that I can do it unconditionally inside that loop. But This is the smallest. Oh, hold on. Something bad happened. Stop. Float extras. What went wrong? Exit. No matching pattern error. Okay, so let me just double check. That it definitely was that most recent commit. No, it wasn't. Okay, so that one's fine. It's this one that's the problem. Okay, I should have been paying more attention to that. This is, I mean, obviously this is my fault, but part of the problem is that I've got slight error blindness because this always happens. I always see error at the end of the test run. And then it's just whether or not I get that green thing at the bottom. So I think I should probably do something about that because that's my excuse for having got myself into this situation. Destructively consume S expression. Well, why don't I, instead of, let's do this in a rebase and then I'll be able to continue. So this is the problematic commit. What did I do? Destructively consume S expression in parse instruction. We need to preserve the original S expression. But it's going wrong inside parse structured instruction. Okay, let me just remind myself of the change here. So this was one of these indentation specials. So it used to be that we'd unconditionally pop or shift the opcode off the front. Oh, is there anyone else that's... Does anyone else care about the S expression? Yes, look. Poo. Parse structured instruction is in the same boat. But I didn't notice it because it's all the way down here. Okay. All right. That makes sense to me. So this needs to go up here. And I think this actually does need to be a case. Case S expression first. In numeric opcode, do that. In block loop if, do that. Else, do this. Yes, that makes perfect sense. Because it was all the way down there, I'd forgotten that this also needed the original S expression, not the one after the opcode had been shifted off. Thank goodness for tests. Yeah, that was very silly of me. I apologize. So let me amend this message. Preserve parse numeric instruction or parse structured instruction. Oh. Okay, right. Now, the rebase is not going to be happy there. I think I'm just going to restore theirs because it's an easy change to make. I know I just did this, but I quite often do this. Sometimes the brain juice required to resolve a merge conflict that was caused by a change I literally just made in the editor is significantly greater than the brain juice required to just repeat that change. And in this case, I just can't be bothered to unpick that merge conflict. I'd much rather just mindlessly do the same change again because I don't have to think to do that. Like, it was a simple syntactic change to do this in the first place, and so it's no biggie for me to do it again, whereas for me to pick through those conflict markers and figure out what bits I could keep and what bits to throw away is like actually more effort. So excellent life advice for people who are too lazy to use Git properly, I suppose. Yeah, that all looks correct. So that actually hasn't touched that part of the code. Oh no, it has. It's just inside this. Yeah. Because I moved it up. Yeah, okay. Phew. Okay, let me just do a full test run to convince myself that I haven't caused any bad murders. I do sort of feel like I feel like this parse instruction method is a bit lopsided, like in terms of its level of abstraction, because it starts out just delegating to other, this is something that's really just checking, like an S expression parser, like any, in any recursive descent parser, you always have a conditional like this, right? Where it's like, if the next thing that I can read is a bracket, then recursively parse a list, or if the next thing's a quote, then recursively parse a string, otherwise parse an atom. So this is at a nice sort of consistent level of abstraction, and then it's all of these methods are the ones that actually muck about with the underlying stream of tokens or characters or whatever. But here, this has gone a bit lopsided because these ones sort of delegate to other methods that do the dirty work, but then there's a load of inline dirty work here. So just for the sake of argument, I'm going to replace this. I'm going to call this like parse other instruction. Like, it's not a good name, is it? Numeric structured. I mean, I don't know what to call it. I don't know whether to call it like non-numeric unstructured instruction. Like, feels like a bit of a mess. So for now, I'm just going to chicken out and call it that. But now that we don't have that unpleasant argument threading in and out business, it's really easy to extract a method like that. I don't need to thread rest through or whatever. Maybe I'll just call this like parse normal instruction. Like, these are all the boring ones, right? They just have a known static arity. In this case it's 0. In this case it's 1. And in fact, all of these ones with a static arity of, all of these opcodes with a static arity of 1 all happen to take a label or an index, I guess, is what it is. I don't know if there are any that don't. I mean, the things like const takes a static argument that isn't an index, but that gets handled in numeric instruction. So yeah, I suppose I'll call it normal. I can't really think of any. I mean, that's got some other connotations, but I can't think of any word that, it could be like regular instruction or ordinary instruction, but they all sort of vanilla instruction, but those have all sort of got various connotations that are undesirable, so I might as well just go with my first choice. So let's just say extract parse normal instruction. This balances out parse instruction so that it only delegates to other methods rather than being a mixture of delegation and direct dirty business. Right, error successful. Okay. All right, so the thing I actually wanted to do, but that somehow I didn't get around to doing. Oh, yes. I've got a stash. That's what I was doing. Okay, yeah. When I when I noticed the test was broken, I backed out of it. But look, here's what I was trying to do. Let's see how that's looking now, because that might just be working. So if it is, it's going to be something like always consume terminator in consume structured instruction. Let's say it turns out that the caller always needs this to happen. So let's just do it as part of the method, even though it makes it conceptually a bit less symmetrical, because this method doesn't consume the initial opcode. For the sake of convenience. Why do I make commits before the tests have finished running? Okay, so what's going on here? Oh, well, yes, that's the terminator. I guess I really don't have it in a variable anymore. That's fair. I asked for that. Yeah, a couple of things to change here. And that has just made me think that one of them is that really end should be the default. In fact, why don't we do that? All the places where we're saying terminated by end, just don't do that anymore. And here, let's just default it to end. Okay, let me just rerun this. So let's say make end the default terminator for consume structured instruction. There's only one place we ever need it to be anything different, i.e. else. So it doesn't. So it's sensible to have a default that works in literally every other case, basically. All right. So I suppose what I didn't really realize this, but I suppose what I'm doing here is just trying to cut down on a lot of the boilerplate that was making this code harder to understand, because there was a lot of ceremony in it that wasn't particularly helpful. And I feel like getting rid of that ceremony has actually made this a bit clearer. Oh, look, I do want to clean up consume structured instruction, but here I can see... Yeah, I mean, there's all kinds of stuff going on. But principle among the things that are going on is that I think... Yeah, let me see what happens if I just inline these. Like if the body is just parse consume s expression, this is just parse consume s expression, parse expression rather, sorry. These two are... Yeah, I mean, look, there's all sorts of gymnastics going on here. Why don't we instead say else end map, that's the terminator. Well, if we call it terminated by, then we can use hash punning. We can say parse expression consume structured instruction terminated by. Oh, and that's what consequent and alternative are. Um, yeah, previously this was kind of being pushed into consequent and alternative. I'm not sure I like the use of end here now. It's not very idiomatic. Is there any way for me to make this sort of syntactically defensible, something like that? Maybe this is getting a bit too... I'm just trying to sort of regularize what's going on here, basically. I'm worried that this has actually made it harder to understand. I think this is sort of violating my one of my special rules about like what I think I'm prioritizing when I work on this. Like this business, I feel like, well, you can't read this, can you? I think the clarity here has suffered in the service of cleverness, which is not really what I want. So let me find a way to... Well, okay, how about this? How about this just becomes... In here, we're always just... We're creating lots of space. We're just saying we're making a new block with the label we've already read, and here's what the body's going to be. Here we're saying we're making a new loop. Just be relaxed. And the body is this thing. I mean, I realize that that's just duplicating something there. But what I wanted to do was make this kind of similar and say the label's what we've already got. Just relax. And then these two are basically the same as... It's just going to be a really long line, isn't it? Well, if anything, maybe that's a motivation to make the names of these methods a bit shorter, but I think I sort of prefer this, even though the lines are very long. I think this makes it a bit easier. Terminated by else. And then we can leave this one alone. This one is terminated by end, but we don't need to explicitly say that. Is there any way for me to make that more palatable? Not really. I think I'm going to want to give these shorter names, basically. But for now, let's see if that... Forgot my backslash. No, that's not what I want to do. I want to do that. Okay. Okay. Let's say like inline. Local variables for body, consequent, and alternative. This does produce some unpleasantly long lines, but I'd rather remedy this by giving the methods more concise names than do weirder formatting. Like, I think this has got some clarity benefits, even though I know there's some repetition there. I mean, maybe there needs to be something that is It's funny because this method is parse structured instruction, but that's kind of, that's what I would have called this. But that's already the method we're inside, so I'm not quite sure about that. So I'm sorry, I'm bouncing around a lot here. I did want to do something about this. I said this loop structure doesn't really make sense. Let me just sketch this out. So if this was an infinite loop, the first thing we do is shift the opcode off, and then I guess like break if opcode is equal to terminated by. That's basically what I had in mind. And I could just make that another case in this case. But the other thing I wanted to do here was hoist up this this concatenation, because both arms of this concatenate something onto atoms, so there's no reason why this can't be atoms.concat. Breaking my rule about then. Like, that's just concatenating that, and this is just concatenating that. Oh, in fact, why don't I just say atoms gets the opcode, and then this just becomes if opcode in blah, then we do a bit more parsing or a bit more consuming. Is this another situation where I could justify inlining that? I think perhaps it is. Also, hold on, look, this is concatenating. Look, there's all sorts of stuff going on here. This is doing a lot of like splatting and unsplatting. This is unnecessary. I can concat that directly, and then this is just a shovel. I think. I think that is clearer. And obviously this is balancing out the fact that we don't get the terminator as from the result of consume structured instruction. But unlike the other problem, I think this is the only place that we actually want it in the return value. In all these places, we don't want the end in the return value. So I think in the common case, we don't want this. This is actually the only case where we do want it, because we're handling the leading opcode and the trailing end. Okay. I think that's tidier than it was before. I'm just going to say tidy up implementation of consume structured instruction. I haven't changed the semantics of this at all. It's just better organized. Pending test failed successfully. Okay, great. Okay. I think that's all the... I think I've popped my stack to the point where I'm ready to carry on with this to-do list. So I'm sorry, I know I've just been doing 2 hours of refactoring, but I think, as always, if I'm planning to add more functionality to this, I want to make sure it's as neat and tidy as it can be, so that I'm not having to maintain duplicated or wonky code as part of adding new functionality to it. And I think this is starting to approach something that's actually quite tidy conceptually, like I've organized out all of these various. Oh, it's interesting. I've got this parse integer that doesn't conform to that. What I said I thought the deal with parse is, which is that it reads the thing it's parsing. So why is that? I suppose it's because parse integer came from the evaluator, where that means something different. Oh yeah, look, well this is easy. It's easy enough for me to push this through because I can stick that in the float branch. In fact, I can just inline it there. And then in parse integer, I can do it at the top, which is what all of the other parse methods do. Right, we pass in the S expression now. And I think, again, this helps to regularize the implementation, where it's like every method that's a parse takes the S expression. I mean, you know, we're sort of missing. I mean, maybe I'll extract that into parse float. Why not? Takes the S expression and optionally, well, I guess this is doing something else, but this sort of takes an optional argument in the same way that parse integer does, because there's some metadata that it can't get from this S expression that it needs to make sense of it. This has come earlier. In this case, it's come from the opcode, you know, how many bits there are. And actually in this case as well, it's come from an opcode that's already been read, that we know what the terminator is going to be if it's not end. So I think, again, having that sort of regularity is going to make it easier to understand, and it makes the pieces of this parser more composable because they all conform to the same sort of contract, whereas previously everything was all a bit ad hoc. So let's say consume string inside parse integer, and let's say this. Oh, hold on, let me just see the. Okay, yeah, I think that's fixed it, because all of that stuff is exercised very early on in the test suite. This makes parse integer conform to the same sort of conform to the same style as the other methods with parse star names, i.e. we call it with the remaining S expression and it consumes as much of it, and it destructively consumes as much of it as it needs. Fine. Let's just do parse float. That's also going to need to know the bits. Rs integer. You know, this. I was just thinking we could just combine these into parse number because they're. That's fine. Not terribly important what the granularity is here, only that it's. Oh, I mean, that's already doing the right thing. Yeah, that's all looking good. Okay. So let's say extract parse float. Okay. All right. Okay, I'm going to stop just sort of tinkering with it. I'm going to try to do something useful. So I think this is the next thing I want to think about. Refactor ASD parser to store the current S expression as state versus threading S expression through everything. Because again, I think that's going to reduce a lot of the overhead here. Again, looking at how S expression parser works, you don't pass string to every method. That's why we've got an instance of the parser, is so that the parser can maintain parsing state internally. And then this just becomes very, it's sort of, I don't want to say declarative, because this is the most imperative code you can possibly write. That's just mutating the state of the receiver. But like, it's descriptive, because it's not messed up with having to pass the S expression everywhere. Oh, the string everywhere. So let's try that. So if I make an attribute called S expression, and then here I just do self.sExpression equals that, and like just not think about why that's happening, but just use it as a replacement for the argument to parse expression. And yeah, again, leaving unfold out of it for now. It's really the parse methods that I'm thinking about. And the reason for that is because unfold doesn't mutate S expression, but all of the parse ones do. So that's what I'm interested in, is keeping that as state on the parser, and then have the parse methods mutate it as they parse stuff out of the S expression. So just naively, can I just do that? Let's see. Excuse me. Oh. Yes, of course, that was a test. Well, it's looking promising. So can I just continue? Can I just run down the file, just removing all of the S expression arguments? Is that how that's going to work? Oh, no. Oh, we've got a recursive call to parse expression. Oh, no. Of course. In fact, we call this all over the place. Okay. I think... Okay, right. What I'm going to do... So there's a problem here, which is that we've only got one piece of internal state here, this S expression. But because there's a recursive call here, we sort of effectively need to overwrite it and sort of say, for the duration of this call, the S expression is going to be something else. But then at the end, we want it to go back to what it was. So I guess what I'm saying is... yeah, let me unwind what I did here for a second. If we leave this with its argument, so this is essentially, I don't think we've really changed anything, we just added the... I think this is the only place where we sort of recursively start parse. This parse expression is like the top level entry point into expression parsing. And I think that this is the only place where we're going to have this problem, where it's like all of the other places, all of the other times we're calling parse, we're just calling it with whatever we were parsing anyway. Yeah. But the problem here is that we're not calling it with whatever we were parsing anyway. We're calling it with something else that we have cooked up. So there are two ways we could deal with this. One of them is to have an explicit stack that we sort of, self.stack, or equals empty, and then stack.push whatever the old S expression was, and sort of keep a stack, and then here we're going to sort of S expression equals stack.pop. And sort of have every time we want to start parsing a new expression, we push the old one onto a stack, we reassign the attribute to be the one we want to work on right now, and then when we're done with it, we pop the old one off. But I think that's overkill in this case, because we can just use the Ruby call stack, because as we've seen, or as I've hypothesized, I think this is the only place that we actually need to do this. And so there's not really any point having if these had to be in different places, if you could arbitrarily start parsing a new expression at any point and finish parsing the previous one at any point, then we would need an explicit stack like this, because it wouldn't coincide with the Ruby call stack of the recursive descent parser that we're writing here. But because it does coincide, I don't think we need any of this. I think I can just use the stack frame of this call, this parse expression call, to say something like, previous S expression equals self.S expression. And then instead of popping that from a stack, I can just restore it by saying self S expression equals S expression. So this is like saving whatever the S expression was, which will initially be nil. The first time we call this, it will save that, and then it will do some stuff, and then at the end, it's going to restore the previous state of affairs. So if we're doing this, if we're 10 recursive calls deep, then each time a call returns, it's going to, the stack frame of its caller is going to have a local variable that has remembered what the previous value of this S expression attribute was, and it will restore it. And then again, each time we return, each revived stack frame is then going to restore the old value of that attribute. So I think, I'm not explaining this very well, but I think that's going to work okay. Specifically the thing that we want to do is overwrite, sorry, this should be previous S expression. My whole explanation didn't make any sense because I'd got that wrong. Self S expression equals S expression. So equals this argument. It's a little bit messy, but I think that's going to work. At the moment, it doesn't do anything. This is just mutating an attribute that no one cares about. So hopefully that shouldn't change anything. But I think that that's going to allow me to remove the S expression argument from all of the rest of these, because like I said, all of the rest of these, they're always just calling the S expression they pass in. It's like a slightly nicer version of the threading the rest through unnecessarily. Here we're just always passing it on. We're always just saying, well, the S expression that I had anyway, I'm passing that as an argument, and so we might as well just store that in the state of the parser, because it's because then we don't have to pass it in as an argument. So let me see where I can get away with that. Parse integer, right? So that can just be tell me how many bits. That can just be tell me how many bits. That can be okay. So that's already making these lines. I said I wanted to make those lines shorter. It has already made them shorter. Um, yes, we don't need that. We don't need it there. We don't need it there. We don't need it there. So I think that's what we need. If I'm right about this being the only meaningful recursive call that happens, and so we need to do this kind of saving and restoring, because I think, I'm sorry, I didn't really interrogate this before, but yeah, I don't even know what sorry, wherever the failure was. I didn't debug this, but I guess, yeah, I didn't need to debug it. It was, yeah, I perhaps didn't really explain my thought process here, I'm sorry, but I'd forgotten that there was a recursive call, and that's immediately problematic with respect to just saying, well, we're just going to have a single attribute that stores that piece of state, because if the recursive call needs to overwrite that piece of state, then we've immediately got the problem of what happens when we return. But because there's only that one place where that happens, I think that this putting it on ice in a local variable and then restoring it again afterwards, I mean, we'll see if there's, I'll just shut up and run the tests. Like if there are any other such problems, parse instruction, wrong number of arguments. Now, is that a similar class of problem, or is it just, have I just overlooked a place where, yes, I have just overlooked this. So yes, that was the whole point of this, right? Was that we squirrel this away in the state so that we don't have to pass it in as an argument. Okay, let's try again. Okay, well, on the assumption that that's going to work, let's say store the current S expression as state instead of always passing an argument. Okay, failed successfully. What do I want to say about this? This is slightly complicated by the fact that parse expression recursively calls itself eventually or indirectly. So we need to save the previous value of the S expression attribute and restore it after the recursive call. This isn't currently a very tidy solution because the parse expression method still takes an S expression argument, unlike all of the other parse methods. I'll try to fix this next, because I mean that was a sort of a hand over hand refactoring that allowed me to remove this argument from everything except this. But really what I want to do is hoist this outside of this concern should move outside of parse expression so that I can get rid of this argument entirely and just say that by the time you call parse expression, it's got the right value in the S expression attribute, and that you, the caller, are responsible for restoring the value afterwards. But unfortunately, there are 5 callers of parse expression. I think what I'm going to do is extract a helper to do this. So rather than, because look, I could, instead of doing this, I could just say like, this could be like with input s expression do like that, and then that with input s expression would just be this, with a yield in the middle. Maybe this should be called with s expression, but then it feels like it just gets a bit repetitive. I mean, it could just be called with. Oh, what about if it was like this? Yeah, maybe that's the best of both worlds, because that's kind of putting it in the name. Yeah, I kind of like that, although I suppose it's a little bit strange. So this is just squirreling it away in the... squirreling it away in a local variable. I'm just thinking I can do this. Is that too naughty? Is this too naughty? Maybe that's okay. I think that's all right. So this is just, you know, the right-hand side is going to be evaluated here, and it's just going to be... Maybe this would be easier to read if it was... Sorry, I know I'm faffing here. Yeah, I think maybe that's even nicer, actually. Except, apparently, what I just wrote is not valid syntax. Oh, stop it. Oh, right. Well, that's not a thing, is it? You can't... Yeah, you can't do that. That's not how pattern matching variable binding works. Okay. Well, that's fine then. I'm fine with that. So let's say the order of the methods in this file is not very meaningful, so I think maybe that needs to be cleaned up at some point. But extract with s expression helper from parse expression. This wraps up the logic necessary to save and restore the current value of the s expression attribute, which will allow us to pull that functionality into the caller of parse expression rather than making it part of the method itself, thus requiring an s expression argument. Okay, everything's still good. So the point of doing this is that it allows me to do that. And I'm no longer going to do that inside this method. I'm going to do it in the callers. So that means that rather than passing consume structured instruction in as an argument, I'm going to say with S expression. Oh God, what a mess. Consume structured instruction. Parse expression. I don't really like this. Let me just commit to the bit and then think about whether I actually want this. This seemed like well, frankly, it seemed like a better idea when I assumed that the argument was going to be called S expression. And I thought I was going to be able to use hash punning. But it turns out in none of these places can I do that. Okay, and then this, yeah, again. Doesn't really feel like a win for clarity, if I'm honest. Well, does it even work? No. Why not? So... Oh, okay, I know why it's not working. It's because in these cases, unlike in the ones up there, well, I guess we care very much here, actually. It's the return value of this with helper. Because at the moment, this yield is not returning its value. It's this that is getting returned. So what about... Because this is really just about putting the world right again afterwards. So can I just put this in an ensure block so that it's clear that this is just about sort of doing cleanup afterwards? Is that too horrible? Yeah, so let's fix the problem. But I'm going to stash that because, and that means that test is not useful, because I think that ended up looking a bit horrible. I'm just going to go for with input, like I initially did, and I'm going to get rid of the keyword argument. It's not a great name, but I feel like what happened before was too much of a dog's dinner. So yes, that's correct. With input, somehow miraculously that has survived. But all of this, so wherever you see with S expression, What I actually meant to say was with input. Okay, that's slightly less disgusting in terms of the API, I think. In fact, it's now short enough that I feel like I can defensively do that. Maybe I shouldn't inline this. Maybe I should say, like, you know, unfolded. Because then at least I've given it a name. It's made this line shorter. Again, I'm contrary to appearances, I'm trying to strive for clarity here. I know I'm going down some pretty opaque cul-de-sacs here, but I'm just trying to keep it as simple as possible, or as clear as realistic. These aren't amazing, but I feel like part of that again is just how long that name is. Like, I don't think it's conceptually too complicated now. It's just that name is really long. So let's say use move with input. Hold on, does this also... I think what I'm going to do, rather than bother to talk about it, is just make this change about the return value just part of the previous commit. Like, just pretend that's what I did all along, even though the return value doesn't matter there. Like, this is the thing that really preserves the semantics, is you still get the value of the block. Like, if I was clever, that's what I would have done the first time. So let's just pretend that I'm clever. Okay, so now let's say lift with input out of parse expression to all its callers. Well, let's just say move. This brings parse expressions signature in line with all the other methods with parse star names, i.e. it doesn't take s expression as an argument, but relies on the s expression attribute stored in the parser state. So I think now that, so that's it. I have actually done this. Store the current s expression as state. So that means that all of these parse methods just operate on the current s expression rather than taking an argument, which I think is actually quite nice. An obvious thing to do is to sort of basically this is kind of what Chris was talking about. I've got quite a lot of this business. There are two things that I do to the input, right? I either peek at it, which is sExpression.first, or I read it, which is sExpression.shift. So I think I should probably just encapsulate those two things. I suppose they'll go right at the bottom. So peek is sExpression.first, and read is sExpression.shift. And then hopefully those are the only places that I need to, that can push the current s expression, like, out of the abstraction level that these parse methods are operating on. They don't actually talk about the S expression. They just talk about peeking and reading. Peek. Yep, yeah, yeah, yeah. No. And shift. Yeah, 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 yeah. No. Okay. Doesn't seem to have broken anything. Okay, so how well encapsulated is that S expression now? Obviously, we get past it in at the top level. Oh, I've just realized I don't need to use that with input helper here because I could just assign it. I think that might make it clearer. I think if instead of unfolded here, I was just doing self.s expression equals, because that makes it look more like what happens at the entry point of like this parser, you know, like that's what I'd expect to see in the kind of the public method that you call. We have to like initialize the state of the parser and then we dive down into some recursive thing that's going to be consuming that state. And I think using with input here kind of obscures that. But I think if I do that, then in terms of understanding the public API, you don't even need to know about the fact that there's this sort of kind of re-entrant recursive part of the parser that you have to worry about. Yeah, because it's, and actually this sort of makes it more explicit that this parse method doesn't get called recursively. Like it just mutates the state of the parser and then we call parse expression and stuff is going to happen and then we're ready to go. Well, we return the value. Yeah, okay, that's still working. Okay, so hold on. I'm getting in a bit of a mess here. Oh, I think I can just, it's okay. I can just add this bit. So there's no reading or peeking in there, so I can just pretend that that's what I meant in the first place. Yes, maybe it deserves a little explanation. I've intentionally not called with input at the very top level, i.e. inside the public parse method, because I think that makes it clearer that parse isn't recursive and doesn't need to even know about the fact that parse expression might need to reassign S expression, the S expression attribute when it calls itself recursively. This lines up nicely with e.g. S expression parser parse, which does almost the same thing with its input string. Okay, I hope that's a sufficiently convincing defense of that decision, because I know it's a bit weird to have introduced a helper specifically to do this assignment and then not use it, but I feel like the helper does more than that assignment, and actually this makes it unarguable that we only need the assignment at that point. I mean, this assignment could just as well move into the constructor of the parser actually, and there's no real reason why it doesn't. you know, I could just move that into the constructor and then you just call parse with no argument, but then it would just be calling parse expression. So I think at the moment this is semi-helpful. I don't know what I'm going to do to the public API here when I want to be able to parse a module. Well, maybe modules are the only thing you can parse through the public API. No, because you need to be able to parse expressions for the assertions and stuff. So yeah, anyway, that's I'm not working on that right now. Okay, so this is extracting peek and read, but I wanted to, the reason I was, the thing that my brain snagged on, the reason my brain snagged on this is because I was just doing a sort of an audit of who still refers to that S expression attribute. That's just an argument. In fact, as before, there's no reason that unfold even needs to be in this class, but that's where it's in a slightly more appropriate place than it used to be. Oh, so this needs, what do we do in S expression parser? What makes this stop? Oh, can read terminated by. Yeah, okay, so there's no, I thought there might be a helper that looked for like EOF or something, because that's what we're saying here, you know, this is like until EOS or EOE, depending on what you think S expression begins with. Maybe this should just be like until finished. Like, I quite like for all of the accesses to that attribute to be done through this very tin pot API that just asks for the peek, the read, or are we done? Can I just do this postfix? Is that too gauche? I mean, I sort of like that as the definition of parse expression. S expression empty. And then I think we've just got unfold and with input. Yeah. That's where I wanted to get to. So now all of the details of this S expression are sort of hidden behind those helper methods. Let's just double check. But let's say this is extract, finished, peek, and read helpers. Between them, these completely encapsulate access to the S expression stored in the parser state. So all the operations of the parser, ignoring unfold, which isn't really part of the which is a separate phase that just happens to live in this class at the moment. So all the operations of the parser can be written in terms of these slightly higher level so all the, I want to use the word operations down here, parsing methods, operations, instead of inspecting, mutating S expression directly. I guess this is, it's really the fact that it's self.S expression that's the relevant information there. Imagine if there was a version of Git that let you put an octothorpe at the start of a line. That would be a game changer for my commit messages. But for now, the game remains steadfastly unchanged. So have I finished faffing with this? I mean, it'd be great if the answer was yes, wasn't it? Because I'm 2.5 hours in and I haven't really done anything yet. I've just been pushing the peas around on my plate. I can see there's more stuff I could extract in here. There's some hashes I could pull out. There's some helper methods I could pull out. I suppose it occurs to me that this consume structured instruction is actually just a wrapper around read. Like, this is something that just iteratively calls read and returns the array of results that it got. So this is some kind of... This feels like more... This is definitely not a parser, like this, in the sense that this doesn't return an instruction or anything in the world of instructions. You know, even parse integer returns an integer that's ready to be aggregated into an instruction, but this isn't that. This operates in the world of S expressions, and it's just, it wraps around read and it sort of spins until you've... What would happen if this was just read until, and like, let's make this a sort of default positional instruction, because I'm just thinking about the ergonomics of using this. Read... No, it doesn't work because you don't always provide the terminator. Read... Maybe it's like read nested and then terminated by... Yeah. It's something like that, isn't it? I'm not quite sure what the... Maybe nested's not the right name for it. I've already called them structured instructions, right? So maybe it's read structured. Yeah, because it's not... Yeah, I think it's because the language calls them structured instructions, it feels like that's what I should call this. But let's say that consume structured instruction, let's just call it read structured. I think that's, well, firstly, it is a bit shorter, and I'd already expressed my desire to make these lines shorter. And I think that makes it clearer that this is really just a wrapper. Oh, I still called it read nested down there. The reason I'm pausing is because I'm thinking about, I really want to extract this out to be its own method, and I just can't think what it's going to be called. But for now, I think read structured is probably the best name for this. Let me just check I haven't broken anything. So let's say rename consume structured instruction to read structured. And let's say now that we have a read method, it's clearer that this method is just a wrapper around it, calling it multiple times until it finds the end of whatever structured instruction we're currently trying to parse. So when we do this with input read structured parse expression, what we've done is we've just entered, we're inside the body of a block, or we're inside the consequent or the alternative of a condition, or we're inside the body of a loop. So I feel like what I should be able to say at this point is like read nested expression in these places, or certainly here. Oh, and I guess here I should be able to say read nest terminated by else. But it's not read, it's parse, isn't it? So I think this is probably what I want, is to be able to have a parse nested expression that all it does is that. And I guess it's going to have a terminated by argument. And I guess this is going to have a, this is going to delegate it. Does that make sense? I think it does. I think yeah, I think it does. I mean, ultimately, this could just be parse expression now that I think about it, but that would require us to... Okay, let me think about this. Let me think about this first. Okay, this doesn't need to be a long line anymore because, or it can be a long line. It's just this one that's long. Oh, yes, commas exist. So does that make sense? So I'll say extract parse nested expression. I'll say we're doing the same pattern in several places, so it makes sense to wrap it up in a helper. Ultimately, we could use this as our primary means of parsing expressions, but only if read structured could cope with hitting the end of the input instead of finding a terminator. Oh. Right. Okay. So actually this needs to hold the default. We don't need it in both places. And that's going to require this, which arguably is a little bit more explicit anyway. What is Vim playing at with that bracket highlighting? So is there an opportunity here? Yeah, that's correct. I'm sorry, I know I'm still doing this. I realize I should have stopped refactoring by now, but this feels quite juicy. It feels like I'm getting somewhere with this, because that method I just introduced, parse nested expression, it's basically this. Sorry, that's not articulate at all. I suppose what I'm trying to say is that if you look at the S expression parser, parse expression takes a terminated by. And that gets called at the top here with parse expressions until you reach the end of the input. So that's what \z is matching here. But then when it gets called recursively, we pass in, a closing parenthesis, for example, when we're trying to parse a list. And there's something very similar going on here, which is when we call it at the top level, we sort of want to say terminated by, being done. And really what we mean by parse nested expression here is just parse expression, terminated by end. Because end is essentially the equivalent of close bracket. I know I'm adding back in these things that were previously a default, But the reason why there's no default, the reason why I'm getting rid of the default is it means that if we could somehow make this work, if we could make it work that you can call parse expression and you can explain what you want it to be terminated by, then because that's what the point I was trying to make is that this is parse nested expression is essentially just the same as parse expression. It's just that at the moment parse expression stops at the end of the input, and read structured reads up until something. So maybe this could just be, okay, I'm just going to sketch this out. If in parse expression we take an optional terminated by argument that is nil by default. So let me think about what this means. So if terminated by is nil, then we do what we did before. Else something else with input read structured terminated by parse expression, basically. Yes. Yes. Does that work? That seems mad. But essentially what I'm doing there is using nil to mean the end. You know, keep parsing until you've eaten the whole thing. But if you do provide a terminated by, then we're gonna, instead of consuming until we run out, we're only gonna eat as much as we need. Oh, no, see, that didn't work. So ultimately not a very good idea. Why didn't that work, though? So let me look at the diff. Because it shouldn't change wherever we were previously calling parse expression recursively. Oh, it's actually only in those places. I'm not sure I understand the problem with that. Oh, of course I understand the problem with it. Okay, I'm just not thinking. I'm sorry. It's that these lines belong inside there, which would have been clearer to me if this was using tap, which perhaps perhaps it should be. You really can't separate these. This is the thing that's spinning and returning its input. So hold on, read structured. Right. Okay. So I think now okay, yeah, stuff is starting to fall into place here, I think. I didn't realize this is where this was going to go, but I think it's I think this is starting to coalesce into something that I can just relax and walk away from, which I know is what all of the millions of people currently watching this video wish I would do. So yes. Yes. This is nice because it's so much closer. I mean, this wasn't my intention, but it is so much closer to how the S expression parser works that you do, I mean, ignoring the fact that this is parsing multiple expressions, it's the same idea that we start at the top and we pass in this kind of, I mean, this could just as well have been nil here. It was just convenient that actually you can express with a regular, when the input's a string, you can write a regular expression that means keep going until the end. I mean, I guess if I'd synthesized a fake token at the end, you know, if there was like an EOF token, well, maybe I should do that. Maybe that's clearer. Because then this conditional goes away. Sorry. Okay, let's try this again. Yeah, this is an improvement. It's an improvement. I think maybe sticking a dummy token onto the end is a good idea. That's what I've decided. But let me commit this. So let's say incorporate parse nested expression into parse expression. These two methods differ only in what they're reading until. One of them reads until the end of the input, the other until some specific atom. So we should really just combine them and support, in this case, nil as meaning the end of the input. I suspect I can do better than this by appending a special atom and using that as the terminator, but I'll look at that next. Okay, so what I wanted to because what I want to do next is note that what I actually wanted to do, this read structured, I sort of wanted to call it read until. And it didn't make sense because the argument was optional. But now it's not optional. And I think I'm just going to call it, instead of having the keyword argument, I think I'm just going to well, maybe it's okay. It really doesn't matter because I'm only calling it in a couple of places. Well, one place and then recursively. Yeah, okay. I mean, that's a small change. Rename read structured to read until. This was the name I originally wanted, but it doesn't make sense when the argument is optional. now the argument is required, I can finally use it. Okay. And then the thing I was saying here was that if I say, if I say, end, oh no, I can't call it end, terminator equals, I mean, it can be anything. Let's just make an object. And then we set the S expression to be that plus the terminator. And then we parse expression terminated by terminator. I mean, maybe I could call it like end of input or something. Yeah, that's okay. So I'm guaranteed to get an array back from, well, this is a flat map, right? So I'm definitely going to get an array back from that, and then I can just add this special end of input marker onto the end. And then now this is no longer optional, and you may not pass nil in. So this whole case goes away, and instead we get this. So there is no recursive call in there. It's just unconditionally we read until the thing that we're terminated by. I mean, that is a bit annoying, isn't it? Because it means the very first thing that we do is spin through read until to get the whole input. But maybe that's a problem for future me who does this with enumerators. Because other than ignoring sort of performance concerns, I think this is a much more regular way of dealing with parsing expressions, which is that you need to know, because we might call parse expression recursively when we're down inside the body of a loop or something, we need to know how much of the input to chew up before we try to parse it. And I think having this single entry point that is parse expression is way more regular than having a special alternative for nested ones, and having nil is worse than having this sort of uniform. I mean, I guess I could actually use nil for the end of input here, because nil is a special object. But I think I prefer having some kind of special, I don't know why. I feel like if any nils creep in, I don't want them to be able to, I don't want, anyone else can produce a nil, whereas only I can produce this magical sentinel object that terminates the input. So I think I'd rather retain that control of it. So let's say use is sentinel the right word? Or tombstone or something, I don't know. Use a special object to mark the end of the whole S expression. This allows us to avoid the conditional on nil, because we now always provide a terminated by CF S expression. S expression parser. Parse expression. Is that what it's called? parse expressions currently. Instead of allowing nil to have a special meaning. This has performance implications because we now do a full scan through the entire S expression before we even start parsing anything. But I think the clarity benefits outweigh the performance costs. I can mitigate this later by moving to enumerator instead of arrays. Well, let's say if this turns out to be a legitimate performance bottleneck, then I can mitigate this. If this later turns out to be a legitimate performance bottleneck, then I can mitigate it by moving to enumerator instead of arrays of atoms, right? S expression parser already produces an enumerator anyway. So we could just consume that here. Okay. All right, I think I've apologized enough for tinkering with this too much. The final change, I promise, the final change I'm going to make is that for these methods where we start out with an empty thing and then we collect it and then we return it, I'm going to use tap. And I think instead of result, I'm going to call this expression, because that's what we're doing. And we are parsing an expression, which is a collection of instructions. And here, yeah, I think atoms is a fine name. I think that'll help me to avoid making silly mistakes like I made before when I sort of forgot that that was an intrinsic, that this was sort of an indivisible chunk of work. Laying it out like that makes it clear to me. Use, is it just objects tap? Yeah. Use objects tap in parse expression. Well, to accumulate an array. It's subjective, but I think this makes it easier to see what's going on. This would be even clearer if we were inside an enumerator and could simply yield each entry rather than adding it to a result array, but that's a job for the future. Okay, well, like I said, I'm going to resist the temptation to mess about with this anymore because I've spent 3 hours over tidying this up, but I think, in my opinion, that was worth doing because this is now much more organized and principled than it was previously. And like, I think the code is easier to read. There are a couple of tricksy things in it. But overall, I think this is much improved, and I feel much more confident in my ability to maintain this and to add new stuff to it, because now I feel like I understand how all the pieces fit together. So for now, I'm going to park this. I'm not going to, because I want to actually make some more tests pass. So I'm going to park these stretch goals. I promised I wasn't gonna update. We should just use if match equals blah dot match atom, so we can pattern match the match data. That was my insight about that. But I'm just gonna, I'll come back to that. And yeah, return an enumerator, that's work for another day. Okay, so I'm gonna sort of draw a line in the sand there and say I'm done. 30 commits later, I'm done playing with my food as far as the AST parser is concerned, and I'm gonna switch gears and go back to the interpreter and try and get some more tests to pass, because right now this if.wast is failing. So it's saying, let's take a look. Multi. Oh, sorry, we're in the wrong file. So this is, so what happens here is that this is a function that has got, that returns two 32-bit ints. It takes a single parameter. So if that parameter is true, then it just calls dummy 3 times. If it's false, then it calls dummy 3 times. Okay, so this is going to call dummy 3 times. If its argument is true, then let's ignore these calls to dummy because they shouldn't do anything. So if its argument is true, it pushes 8 onto the stack. Otherwise, it pushes 9 onto the stack. And then it pushes either 1, 2, 3 or -1, -2, -3 onto the stack. And then it drops the last two things. So it pops off the -2 and the -3, or the 2 and the 3. So what should be left on the stack is, if the argument is true, then we should have 8 and 1. And if it's false, we should have 9 and -1. Eight, 1, 9, -1. 9 -1, 8, 1. Yeah, okay, it's just the other way around than I was expecting. But that's because it was a test for... Yes, okay, yeah. It's because of the way truthiness and falsiness works, it was just the other way around. But, okay, so that makes sense. So there's a few things that we don't support here. I mean, why is this breaking? Unhandled exception. But I mean, at the moment, assert return, I don't even know what it does in the presence of multiple expressions here. I mean, I imagine it's only going to evaluate the first one. So I think that's the problem, is that it's probably, it does this invoke, and then I think it's expecting that to leave, yeah, it's expecting that to just leave the result on the stack. So it's assert return we're worried about here, and then it just pops the result off the stack. Oh, and then, okay, so that's why, presumably that's where it's breaking, line 110. Yes, that is line 110. So that all makes sense. This is just popping one value off the stack. And unsurprisingly, the stack is not empty, because this function, we haven't seen or even vaguely thought about this before, but this function returns two arguments, two results. So, here to do pop the right number of values. Wow. Pop the right number of results. And then here, that I remember being confused by this recently, this expected dot first. Here it's like compare the right number of expected values. Yeah, so this is like actual values. So this whole thing is sort of been bodged by some fool into ignoring everything but the first. Yeah, this whole thing, like it says case expected first. Yeah, actually, I mean, this is the problem. Because we need to do this kind of pointwise. Like, if one of these was f32.const nan : arithmetic, then we need to use this branch for that specific value, and for the other expected value we need to evaluate it here. So, and also, yeah, this is nonsense. Oh no, it's not. No, that's okay. This is yeah, no, this is okay. This is just for evaluating. Yes, the assumption, yeah, no, that makes sense. The assumption here is that it's evaluating the expected value is only going to return one thing, and I think in all these cases, I think that's true. Whether that's a correct assumption in general, I don't know, but okay. So I'm understanding this now. So ultimately, we need to know what the right number of actual values is here, which I think is just the length of expected. So let's make this actual values, and let's say stack.pop expected values.length. I think that pops the right number of values, but now we're going to get a different failure, not least because expected value is now no longer... Oh, I guess this is just expected. Sorry. Yes, we don't have the expected values. Okay, yeah, that's what I was talking about. Actual value is now not there. So, but at least the point is we got past this. So that's fixed my immediate problem. It's that you're not supposed to pop just one thing off the stack. You're supposed to pop... Let's do this, because I think that's what I'm doing elsewhere. Yeah, in all these places. I mean, what's my rationale for that? And why does this not do that? Well, maybe it's because we're not actually... Okay, it doesn't matter, does it? It's just an assignment. In all those other places, we're deconstructing it to take the array apart, but in this case, we're not. So I'll just let that. I'll just leave that alone. Okay, so now that we've got the actual values and we've got the expected like patterns, well, they could be patterns, they could be actual expressions that we can evaluate. Oh, so this is in nil, like this is for the case where there are 0 expected. So I think that will go away when we find out how to deal with this. I mean, this whole thing needs to be... This whole thing needs to be inside, like, expected... I was pausing there because I was trying to think about, like, what do we do about success? I think if what we do is map... So if here I say successes, because that's all we care about, actually. The whole purpose of this block... we also have the expected values. Okay, all right. All right. Let's take it one step at a time. Let's make this an each. So this is now going to be a case. I mean, maybe I could just move this inside the each. That might be easiest. Yeah, it would. I'm going to do that because otherwise you've got the problem of getting all of these values outside of this loop, and I think it doesn't... The error message here is not going to be meaningful. So I sort of want the assertion failure to happen sort of point-wise. So if it's the third one that fails, I want the failure message to be about the third one, to not be about all of them overall. I think that's more useful. Oh, except the dot printing needs to happen outside. You don't get 3. You don't get 3 dots just because you asserted there were 3 values in your assert return. So I think this just needs to be unless success. Hold on. I haven't improved things at all, have I? I just moved that to the same level. That was very silly. So this actually needs to go here. That's what I was feeling for before, was that it needs to go outside of the expected.each loop. I think my life would be made easier if this was expecteds. And then this was expecteds.length. And then this was expecteds.each do expected. And then this is just case expected. So this is actually flushed out a few things here that were wonky. You know, the fact that we were matching multiple things here. And then there was a case for when there actually wasn't. The nil case was like, oh, if there was nothing there. And then if there's one or more, we just take the first one. Like, that whole thing was a bit of a mess, really. I think this has cleaned that up significantly, because now this is just 0 or more expecteds, and then we just iterate over them. Oh, but I've got to know what actual value I'm comparing it to. Okay, so I need to zip this. Expecteds zip actual values. Yes. Okay, I think that's right. I am wrong. Something's gone wrong, unfortunately. Something's gone wrong in the parser. Okay. Oh, it's because of this. That's not right. I missed that. Okay, look, we've got a lot further. Before it was only... Oh, I need to do something about the... I need to do something about the fact that when you print out the memory, it shows you all of the bytes, which goes on forever. But previously... Well, let me stash. It was getting 1, 2, 3, 4, 5, 6, 7, 8 tests in. Now it's getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tests in. So I guess all 4 of these multis, it was failing on the first one. Now it's doing all of them, and now it's failing on the nesteds. So at least we know where it's failing now. Okay, so what is this doing? It's basically support. Yeah, support multiple expected values, or support multiple expected values in assert return. It's not a method, it is a piece of syntax. Okay. So that's definitely progress on this test. But now we're getting this undefined method square brackets for nil. So that suggests to me that because it's happening in this locals.slice, so that's on line 210. Oh, that's not helpful. 236. So it's here. We're trying to evaluate a local get instruction. We're trying to get local. Well, I don't know what index. Let's see. Let's do some puts debugging. Locals, locals inspect. Puts trying to get local with index. Yes. Okay, these nils are fine because this just means they're locals with the first one is the name. So as long as we're getting them by index, I mean this is why I need the S expression parser to have that identifier context so that we don't get this. If I didn't have to worry about names, then locals could just be a flat array instead of this associative array thing that we've got going on. So this doesn't seem right to me. I32. That doesn't seem like something that's supposed to be right. So there's only one local here. It's called I32, which seems wrong to me. And then we're trying to get the 0th one, and then we're trying to get the 1th one, and there is no 1th one because this thing is only has length 1. So the only valid index is 0. So something has got screwed up there. I don't know what. Let's read the code and try and figure out. So it's this first one that's failing. We're calling nested. So this one was dealing with multiple return values. I don't know what this is dealing with, but I suspect we're about to find out. So this is being called with 0 and 0. So this has got 2 arguments, and we're supposed to get 11 back. So let's see how that is supposed to work. Func nested. Nested? For some reason that GitHub search has now given up the ghost. I'll embiggen this slightly for anyone who's watching on the sofa. I got your back, tiny text person. I am your people. Okay, sorry, what was it? 0 and 0 returns 11. Okay. I mean, I'm really suspicious of the fact that we've got that local called I32, because it definitely shouldn't be. So I know that the AST parser just skips over these, because this is the block type. This tells you what the return type of the, in this case, the consequent and the alternative are. And in a loop or in a block, it tells you what the return type of the body is. So that's just for the verification phase, which we haven't implemented, the type checker, essentially. Certainly these I32s could have got somewhere unintentionally. But why is this nested? Like, what does it do? Oh, it's about nested conditionals. Right, okay, so this is about, there's a top level if, and then you've got a nested if. Okay, I feel like I can't immediately see what's going wrong here, so I want to do some more debugging to see what the problem is. And so I'm going to copy spec test core if.wast nested.wast so that I can just do a focused. I mean, really, it would be nice if my test runner supported this, if I could just focus. Yeah, let me add that. Add support for running a single line in a WAST test. Because I've been doing this quite a lot. I've been just like copying these files and then commenting stuff out so that I don't have to. Oh, that's not the right. That's also not the right. I'm sorry. It's a good job that Vim knows about WAST format. Commenting them out so that I don't have to see all of the debug output from other things. I'm sorry. I was just thinking about whether I want to delete this, but I think I do. I don't just want to comment it out. I want to get rid of it entirely so that I don't have to think about it. So nested. Get rid of all of this. Oh my goodness, where is the... Okay, let's just... Well, I'm going to have to put in a close paren to balance it out, but I think that's it. So let's just check that that gives me the same. Yes, that's the same problem, and now it's failing immediately. So now I feel like I can instrument this by... I suppose I want to see what the... I suppose I want to see what evaluation is doing, basically. So yeah, let's just do that. I mean, it's not the best output. Okay, so what happens during evaluation is that, well, really it's just this that we're trying to get working, isn't it? So firstly, these two consts get evaluated to give us the two arguments, 0 and 0, and they're evaluated without any locals. Okay, so it's immediately gone wrong here where, well, we're trying to do this, we're trying to evaluate this local get, and the contents of the locals is I32 has got value 0, and that is just not right. In fact, have I even implemented support for calling functions with multiple parameters? Like, maybe that's the problem. Oh, I think I did. I thought I did implement that. But it's clearly not working, right? Because there should be two locals here, both with the value 0, and instead there's one, and its name is I32, which is completely wrong. I think the syntax here is, I think it's misreading the syntax. I think it's assuming, I mean, let's have a look at some other... I think it's assuming that the first argument to param is the local variable name, but that is only true if this is an ID. So at the moment, I mean, this is it's a good example of why this module level stuff needs to go through the AST parser, right? Because at the moment it doesn't, and so I'm just relying on messing about with the S expression, and at the moment it doesn't know that this is an ID. So I'm not even going to bother looking at the spec because that's clearly what's going on. So I need to param where we read yes. So this is not right. Because param can either be, well, I am going to have to look at the syntax, but I think it can, so it's like in param with name and type, or in params with types. I think those are the two flavors that we need to support. And when I say name here, this is like ID. And type. In params with type. So either you've got a load of anonymous parameters, or maybe you can keep repeating the IDs. Whatever it is, I should basically I've got to parse it here because I haven't parsed it in the AST parser. So that's my punishment for not having done this to do item. So I called it a stretch goal, but look, it's immediately necessary, which is exactly why I wanted to do it. But I'm already resolved to park that. Once this is working right, I can do the same thing where I can just airlift it over into the AST parser, and it'll already have the right behavior. So I think this is in modules. You can see the stream struggling as the MathJax renders. So I'm thinking about function syntax here. So func, ID type use, local. I think type use is where the params live. Yes. Oh. Oh, yeah. Here we go again. I was like, well, it can't be because it says type there. But here it says a type use may be replaced entirely by inline parameter and result declaration. So this is just another abbreviation. So what we should expect to see instead of type in parens is just 0 or more parameter types and 0 or more result types. So let's see what that looks like. Param, open bracket, param, optional ID, val type. Okay, so there is an optional ID. So there's only one flavor here. There's an optional ID and then num type, vec type, ref type. Oh, no. Look. It's another abbreviation. Oh, God, see this? Oh. I'm going to stop saying this, but this is why I need to take care of this in the AST parser because it's too much for me to cope with here. So this is saying if you've got multiple... So what I said here is correct, actually, with respect to the abbreviations. You either have an ID... So these have to be anonymous. So if you've got multiple anonymous parameter types, then you can just stack up as many as you like. If you want the parameter to have a name, then you can only list one. So sort of something like this, isn't it? Because this matches an ID. So this is in param. I mean, right now it's called name, which I guess I'll live with. So that's this case. We've got a single named parameter. And then this case is actually not param underscore, it's param types. And then we need to know how many of those there are. So it's function parameters concat types.map parameter new. Because if there are 3, or in this case 2, we need 2 parameters. And at the moment, we're just sort of throwing away the actual... We don't care about what that type is because we're not doing any type checking right now. So here it's being explicitly discarded with underscore. Here it's just... this block is ignoring what's being yielded to it because we don't care. But it just doesn't have a name in that case. Okay, I think that that's going to fix this. Yes. Great. No. Yes. Yes. Okay, handle multiple anonymous function parameters correctly. Inside a function definition, a parameter declaration can either be a single named parameter, which is this, or multiple anonymous parameters, which is where I was before this, I think. Where's the information about the abbreviations? Yeah. Here. So we need to support both explicitly. And forgive me a moment to say, this is yet more evidence that we need to prioritize parsing the module S expression in the AST parser so that the interpreter doesn't need to deal with details like this. Let's say further. That sounds a little bit less moody. Okay, so I'm going to remove that nested.wast because we're done with it and go back to running if. Okay, so now it's as bur if last. As hyphen bur if last. Okay, what is going wrong here? Unhandled exception, line 110. What assumption has been violated here? Oh, interesting. Okay, so even though we've popped off all of the expecteds, the stack is still not empty. Well, I mean, I don't have to have this assertion in here. Like, this is just, I put this in here to try to catch, to try to fail fast if things go wrong. I mean, so far that has led me to fixing a legitimate problem. So let's see if this is also a legitimate problem. So this is a function that returns a single I32. Here's a block that returns a single integer. And this is going to branch. So this is going to jump out of the block if so this is the condition. Is that right? Jump out of the block if 2. What does this? As br if last. So if you call it with 0, you should get 3. If you call it with 1, you should get 2. Oh, hold on. Okay, I misread this. I'm still getting used to this weird mixture of folded and unfolded expressions, but here, So this is an instruction sequence, right? So first we push 2 onto the stack. This is not the condition. The condition is this whole expression here, this whole instruction sequence. So first we push 2 onto the stack, and then we say if the argument is true, then push 1 onto the stack, otherwise push 0 onto the stack. And then when this is unfolded, we're going to push 3 onto the stack and we return it. So this thing here is sort of functioning as a not effectively. Like if you pass in an argument that's truthy, then this will evaluate. Oh, no, it's not. This is just the identity. I'm sorry. The 0 and the 1 here were confusing me. But if you pass in something truthy, it'll push something truthy onto the stack. And if you pass in something falsy, it'll push something falsy onto the stack. So really, this BR-if is just in a contrived way testing the argument. So if the argument's truthy, then this branch will happen. So we will branch out of the block, at which point 2 will be left on the stack, because this branch if will consume the value that's left on the stack here. So if we branch out of this block, this will still be on the top of the stack, the 2. So a truthy argument will return 2. Yeah, that's what this is saying. If you pass in a truthy argument, you get 2. If you pass in a falsy argument, then the branch doesn't happen. And we go to the next instruction in the block, which is return 3. So this is going to push 3 onto the stack. Okay, so when we get to this point, there's already a 2 on the stack, and now we've also pushed a 3 on the stack. So this failure is sort of legitimate because this function body has not cleaned up the stack. It's got this 2 on the stack that no one has used, and now it's pushed 3 onto the stack and it's trying to return that. So I suppose the question for the WebAssembly specification from me is, I can think of 3 possible ways of this playing out. Number 1, it's not correct that the stack should be empty afterwards. So if even though this function only returns 1 value, if I pop 1 value off the stack, it doesn't necessarily mean there's not still other stuff left on the stack. That to me seems monumentally unlikely. Like, I think there has to be a verification constraint that says by the time you finished invoking a function that returns a single result, there has to only be a single, the delta on the stack has to just be it's pushed a single value. It's unimaginable that that's not the case. So I think I can eliminate that as an option. But the other 2 options are kind of, well, the other 2 options are that function invocation deals with this. That if I invoke a function whose type is it only returns 1 value, then after invocation, if the stack's got 3 values on it, then it's just part of the calling convention, I suppose, for want of a better name. Part of the calling convention is that you just sort of normalize the stack with respect to the return type of the function you just called. And so therefore you throw away some values in order to make it so that the stack delta matches up with the function you just invoked. That's not impossible, but it also seems quite unlikely to me. And the third option is that that's what return does, and that seems to me to be 99% likely because that would allow you to locally validate the body of this function. Like, it seems, if I was designing this, then what I would be thinking is, during the validation phase, we want to check that the type of the block type of this body as a whole matches what this says. Like, this is effectively a block type for the function body. And surely you want to be able to verify that. Surely you want to be able to type check this body in isolation. And surely there's value in checking that this expression sequence here, all of the paths through it, because bearing in mind that one of them doesn't go through this return. There's a control flow path that just branches. If this branch happens, it jumps over the return statement and it just falls out of the end of the function without hitting a return. So that's one path through here where only one value is pushed onto the stack. But there's another control flow path through this where two values are pushed onto the stack. And I just can't imagine not wanting to be able to verify that both of those paths yield the type that's being claimed here. But if that's the case, the only thing I can see that would make that true would be if return was somehow massaging the stack contents to match the result type of the function so that it looks like this 2 was never here, that somehow it's massaging the stack to throw away this 2 and make it so that, well, I don't know how return works. I don't know if you can call return, well, return is just another operation that deals with what's on the stack. So, I mean, I guess this could be defined with respect to the block type of the function body, maybe. I'm talking now about whether this only ever returns a single value or whether it somehow trims the stack to have n values on it, where n is like the result arity of the current function. I don't know. I don't know why I've just spent the last 5 minutes speculating about how it works, because I can actually just look at the instructions. I guess return is probably a control instruction. The return instruction is a shortcut for an unconditional branch to the outermost block. All right, well, I certainly haven't... Oh, I mean, okay, so that's why I've got this to do here, is that at some point I am actually going to have to make return work like a branch that... Yeah, what this is saying is that it needs to penetrate up through all of the nested blocks to the outermost, to the function body. So that's what you would expect return to do, right? It doesn't matter how many, for example, how many loops, nested loops deep you are. If you say return, those all get unwound and you just return from the enclosing function. So that's exactly what I would expect it to do. I think that's vaguely what I was thinking when I wrote this, is like, that's what I think that return should do, is get you out of the current function body. Outermost block. Yeah, so I haven't even tried to implement that. Ah. Taking a branch okay. So actually, well, let me finish this. But this is suggesting to me that it's not something special about return. It's something special about branching multiple blocks out. Taking a branch unwinds the operand stack up to the height where the targeted control instruction was entered. So what that's saying is, whatever the stack height was when we entered... Oh, God. Taking a branch unwinds the operand stack up to the height where the targeted control instruction was entered. The targeted structured control instruction. quite sure what that means. However, branches may additionally consume operands themselves, which they push back on the operand stack after unwinding. Forward branches require operands according to the output of the targeted block's type, i.e. represent the values produced by the terminated block. Backward branches require operands according to the input of the targeted block's type, i.e. represent the values consumed by the restarted block. I don't fully understand what that's trying to say. This language is a bit tortured, and I'm not sure what the targeted structured control instruction means. Maybe it's defined earlier. So maybe label, you know, branches can only be directed outwards, breaking from the block of the control construct they target. The exact effect depends on that control. So this is saying that a branch targets a control instruction, but this is saying the return instruction is a shortcut for an unconditional branch to the outermost block, which implicitly is the body of the current function. Right, so there is no structured control instruction that's being targeted by the return. It's like this whole outermost block. Branches may additionally consume operands themselves, which they push back on the operand stack after unwinding. So that suggests to me that what return is supposed to do is unwind the operand stack until it's at the point it was at when we entered this function, and then it pushes 3 onto it. So basically, it empties the stack and then pushes 3 onto it. Oh my goodness. But that's not going to be true. The stack isn't necessarily empty when this function gets called. I mean, in the case of this test, it is. But in general, we need to unwind the stack the right amount. Let's just see what it says about execution of return, because maybe that'll be more tractable. But in general, the sort of small step operational semantics in this section tend to be less tractable rather than more. Return. Let f be the current frame. Well, I haven't got one of those. Let n be the arity of f. Oh, right. Right. Well, okay, good point. So due to validation, okay, right. So I haven't actually done this checking, but what this is saying is validation will already have checked that hold on. Let n be the arity of the current frame. Oh, sorry, this is about... So this step here, due to validation, there are at least n values on the top of the stack. Pop the results from the stack is talking about how does return know... I mean, this is misleading. You've got to bear in mind this gets unfolded. So really, the return instruction is on its own, and there's just some stack contents. How does it know how many values to pop from the stack? The answer is, what's the return type of this function? So here, because there's only one result value, this should only pop one value. So this is going to have to... I mean, what's the minimum change I can make here? Let's do stack.pop1 into result. And this is like to do check function return type, or rather use function return type here. Because at this stage, I don't have access to that kind of information. I don't have, this is some context I'm missing. I don't have the current frame. At this stage, I'm just evaluating an instruction. There's no way for me to ask, like, well, what function am I inside? Like, we're not tracking that. So for now, just to get this test passing, I'm going to assume that we're inside a function that only returns a single argument. So I can pop one thing off the stack. And then it says, while the top of the stack is not a frame, pop the top element from the stack. So that... Ugh. So this is interesting because so far we've introduced an operand stack, but this is talking about having, and we don't really know what a frame is, but a frame is going to be... Yeah, activation frames carry the return arity of the function, hold the values of its locals. So locals here is part of the current frame. So we just need to enrich this so that either we take more arguments here, or more likely that we wrap up the locals as well as the return arity and a reference to the function's own module instance. Apparently all three of those things are required as part of the activation frame. But the language suggested that these would also be on the stack. Most instructions interact with an explicit stack. The stack consists of 3 kinds of entries: values, labels, and activations. Okay. So this is... Okay. All right. It's possible to model the WebAssembly semantics using separate stacks for operands, control constructs, and calls. However, because the stacks are interdependent, additional bookkeeping about associated stack heights would be required. Right. So what this is saying is, to make it easy to specify the behavior of instructions like return, they're just assuming that activation frames and values, and apparently labels as well, are all just mixed together in this sort of heterogeneous stack that can have all 3 kinds of thing in it. So it makes sense to be able to say, while the top of the stack is not a frame, pop the top element from the stack. So this is talking about... Yeah, I mean, this is just saying... make the stack empty with respect to everything that's happened during this function. So this is saying, like, keep popping stuff off the stack until you find the activation frame for this function, which means that everything that's been pushed onto the stack up until that point is stuff that this function has pushed, because anything that was on the stack before this function was invoked would be below the activation frame that's been pushed onto the stack. So we're not doing that. We're not pushing activation frames onto the stack. I mean, we could, and maybe that would make it easier to implement, because then I could just sort of literally do what this is saying. But we do also have a... We also do have the Ruby call stack. Is there a way that I can use that here? I mean, basically, in the interest of getting this test to pass, can I just empty the stack here? stop at activation frame. So like there's a lot of mess here. I think that did get me a fair bit further. I think it got me past the if, because now I'm on this table, but that only worked by me assuming that the stack was empty when this function was called, which is obviously not okay. In fact, I'm going to change some control flow effect, which is branch to, what did it say it was? Outermost block. Yeah. And that actually goes at the end. Because we would want... so let's have a look. So I'm going to, firstly, I'm going to update this comment. Update, make return to do comment more specific. I've just read the part of the spec. Here. Which explains what needs to happen here. Let me just copy the appropriate bit. This bit. Thanks, MathJax. The return instruction is a shortcut for an unconditional branch to the outermost block, which implicitly is the body's current function. None of the tests require this yet, but we'll need to implement it eventually. So clue in the comment and git blame will be helpful. Okay. I mean, this is a real hack job, but I think I'm just going to have to... Well, I don't have to, but I'm going to choose to power through this for now because, well, I'll tell you why. Because this spec is not about return, it's about if. And I think the if is working properly. So really, I want this test to be passing. And the only reason it's not passing at the moment is because I haven't implemented return yet. Well, it's not the only reason, but that's the reason why that test was failing, is because I haven't implemented return yet. And I don't want to disappear down a rabbit hole of implementing return. I want to get if working. Well, although it's turning out to be a real magical mystery tour of other features of WebAssembly, so maybe if was a bad choice. I didn't realize that it had all of these dependencies on other pieces of functionality, so perhaps this was just a bad idea overall. I think I'll just commit this and say hack return to empty the stack before returning a value. This makes at least one test pass. What was it? As br if last in if.wast. But it's not the right behavior in general. The spec says well, maybe this bit isn't particularly useful. Maybe this bit is useful. Let f be the current frame. Let n be the arity of f. Three is not very interesting. Pop the results. Pop, well, let's just say n results from the stack. While the top of the stack is not a frame, pop the top element from the stack. This means that we shouldn't necessarily empty the stack, only remove everything that wasn't already there when the function was invoked. But at the moment, we don't have enough context to be able to do that. So I'm just hacking it to make the stack empty, which is enough to make the current test pass. We'll obviously need to improve this when we try to get e.g. return.wast passing, which I assume exists. Yeah, it does. Let's say we'll obviously need to improve this and try to get e.g. return.wast passing, but for now I'm trying to focus on if.wast, on the minimum changes necessary to get if.wast passing. Okay. So now what? I don't know why I closed that window, because I obviously need to look at it. It's more this one. Oh, I've got no idea what tables are. As BR table first. BR table 0, 0. All right, well, what's a table? I've seen... Let's see if we can work it out. So here this is table func ref. Elm func. So this takes two arguments. Oh, one of them is the target of the branch, probably the first one. So this is saying branch out of the directly enclosing block is what 0 means. Go zero structured instructions up and break out of it. So or if it was a loop, go to the beginning of it. So that's what I think that's what that first 0 likely means. And this thing is referring to a table, which I don't know what it is. But this looks like a table. And then it says table funcref elem func. So is this some kind of dispatch table where, like, is this what that's referring to? Well, let's have a look at, like, hypothetically, this could be saying branch to entry 0 in the table. Well, I don't know what table is, except this says table, and maybe this is a table of function references, and maybe this is the 0th one, the 0th element that is a function that's this one, and so maybe this somehow calls this function, like indirectly through the table. As BR table first, let's see what the... So this says, if you call it with 0, you get 0. If you call it with 1, you get 1. Okay, truthy begets truthy, falsy begets falsy. So let's say, if I call this with something truthy, then, so if called with truthy, then call dummy, and then push 1 onto the stack. Otherwise, push 0 onto the stack. And then we push 2 onto the stack. And then BR table. So, I mean, I think the I was going to say the condition is just what's on the top of the stack, but that's how BR if works. Is this like a conditional branch based on what's on the top of the stack? Like, certainly this 2... Oh, this is awful. Go away, GitHub. What a dreadful feature. This is much easier. Can I turn those features off? Oh, I don't know. I'll look at that later. The return value here is either 0 or 1. So this 2 does not get returned. So if we've got 0 or 1 on the stack here, can that in any way correspond to calling this? I mean, this is just the identity, so certainly yes. This just returns its... Oh, this takes 2 arguments and it returns the first one. I'm not sure I can understand from this what this is supposed to do. How does this get 2 arguments? If this is... Because there's only... Well, there are 2 values on the stack here, but I assume that BR table was consuming one of them, but maybe it isn't. So maybe that's the deal, is it pushes either 1 and 2 or 0 and 2 onto the stack. Then this may be unconditionally, yeah, maybe I was getting, maybe that's what I was doing wrong. I was getting caught up in the idea of this being a conditional branch, but maybe this is an unconditional branch that jumps to the 0th function in this this table, which is func, which the first argument is going to be the 1 or the 0. The second one is going to be the 2, and it just returns the first one, which is the 1 or the 0. So that does actually all match up. Let's just have a look at what this says. Control instructions, BR table. vector of label IDs and then a label ID. Ooh. Branch instructions come in several flavors. BR performs an unconditional branch. BR performs a conditional branch. BR table performs an indirect branch through an operand indexing into the label vector that is an immediate to the instruction. An operand indexing into the label vector, or to a default target if the operand is out of bounds. Oh, God. So is that the situation we're in? That this just takes... Right, okay, so I was wrong about... This actually doesn't take... the same kind of index, doesn't it? Label index, label index. An indirect branch through an operand indexing into the label vector. Or to a default target if the operand is out of bounds. Okay, well, that's really not very... Maybe this table down here is a red herring then. Maybe the table in question is this. But let's find out what the default target is in that case. Because 2, the operand here, I think is out of bounds. So I think, yeah, I think I was getting distracted by this table. Because that's for this, isn't it? Call indirect is using this table. I think maybe BR table has just got like an inline table. So it can sort of take arbitrarily many immediate arguments, which is more tricky stuff for my... in fact, how is this even getting parsed? Oh, it's not. Right. That's... okay, all right. I hadn't even read the error, but that's the problem, is that this can't be parsed. Parse normal instruction is trying to parse 0. I mean, why is it not bulked at BR table, though? That's concerning. Parse normal instruction. What would it do in that case? It would read the opcode. There's no else case here, so... I don't know how it's even getting as far as 0. That's very strange. I don't understand what's happened there. Anyway, it doesn't know how to parse that. We were looking for the semantics of this, though. Control instructions. BR table. Oh, vector of labels, and then the last one is like a default. So pop a value from the stack. If that's smaller than the number of labels we've been given, then branch to that label, and we don't even have this branch instruction, but we can fake it by throwing a symbol. by throwing 0 or whatever it is, whatever the label is. Else, jump to this. Okay, all right, fine. Well, in the first instance, I need to support parsing. I mean, this is sort of a special case, isn't it? So how does this work syntactically? Control instructions. MathJax. BR table. Vector of label IDs. Oh, okay, so we just... We just need to keep reading. As long as we can see labels. Oh, as long as we can see label indexes. Does vec have any particular meaning here? Vectors are plain sequences, but with a restriction on the length. Oh, okay, it needs to be less than 2 to the power of 32 elements. Okay, great. Well, that doesn't, syntactically doesn't help me very much. So I think this means the parser is just going to have to keep reading as long as the next thing could be a label ID. So either syntactically a number or syntactically an ID, which is something that begins with $. So I'm just wondering whether there's a way of linking to this table, but I don't think there is. I think it's going to have to be this thing. Okay. All right. Well, let's see. Yeah, I'm really unhappy with that. Oh, I know what's happened. It's unfolding. So this is being unfolded incorrectly because we didn't recognize it. Because any opcode that we don't recognize just falls through here. So that's the problem. So first we need to, I mean, this should really fail faster, but the reason why I did this was so that I didn't have to exhaustively list every single supported, because almost all of the, by volume, basically all of the opcodes have got a static arity of 0. So this fall through does all of the unfolding for add and multiply and divide and all of those other operations are serviced by this single fall through case here. But what that means is that when we're adding new instructions, I've just got to remember this, that when we add new instructions, they're going to fall through the unfolding here and get unfolded incorrectly. So that's why we are reading a 0, is because it gets prepended incorrectly to the BR table. So this is going to be a right pain. I suppose I'll continue it in the spirit of what I decided to do before. I won't treat block, loop, and if as being special. They're just one case among many. So if this is BR table rest, I don't remember. I don't need to remember the opcode here because it's only, I think BR table is probably quite special. Well, if this case ever grows to more than 1, then I will remember the opcode there. But I suppose there's a design decision to make here where it's like, am I going to always remember the opcode? just for the sake of sticking it in the... Yeah, I probably will. This whole unfold function needs to change, but I'm not going to get distracted by that. So what this is going to say is basically so these all just take a generic argument, right? Like it's just called argument, and it's actually different in all of those cases. But what I called it with BR_if is I called it index. So I will call this, in a slight incorrect plural perhaps, indexes, and then I need to sit in a loop here and keep pulling them off. So while rest in something rest something like that. And this needs to return, what does it look like? Oh yeah, we have to, of course, all of the rest of the expression needs to be, yeah, this really needs refactoring, but I'm glad I didn't get too distracted by this. So this is going to be opcode, and then this is going to be splatted indexes, because we have to determine the staticity of this dynamically, or you know, we have to determine the staticity of this by inspecting how many indexes there are here. So what I'm going to have to do here is write a regular expression that matches the syntax of these indexes, which is either an unsigned 32-bit number or it's an ID. So this is either going to be one or more. Yeah, and I need to anchor this. So this is either a number or it's a... We must already have something for label here. Oh no, we don't, because... Oh no, we do, look. Oh yeah, oops, I've left that regular expression. Yeah, okay, well that's not useful, is it? It's just dollar. Dollar followed by... Well, this has already been parsed, so I can just say any character. It's already been parsed by the sExpression parser. So I think that's right. It's either a number or... I mean, and that's probably what we need in all the places where we're picking up labels, to be honest. Like, yeah, we just haven't... It just hasn't happened yet that a block has been labeled with a numeric index. Oh, no, that's not how it works. Blocks can only be labeled with IDs, but yeah, okay, this can be numeric. I mean, when I parse BR_if, oh, okay, because right, the reason why we haven't had to do this yet is because BR_if just always unconditionally has a staticity of 1. So we don't need to know what it looks like syntactically. It's always just the atom that comes after BR_if, like, is the index that it's using, and we haven't had to check it like this. But in this case, because we have to take an arbitrary number of them, we have to do this iteratively. So that becomes the index. And then that's the rest of it. Okay, so I'm hoping that I'm going to get a different error message now. That's what I hope for. I'm hoping it's going to complain about not knowing how to parse BR table instead of not knowing how to parse 0, because the unfolding will be working properly. Yes. Okay, parse normal instruction BR table. So that's what I expected to see. So let's... what have I said previously? One line. I just want to look at the commit messages. I always make that mistake. Oh well, and it doesn't even. I didn't want to see the diff, but okay. Say opcode, not instruction. Parse const instruction. Oh. Be here parse const instruction. It's like that's actually not a change to unfold. You are confused. Let's have a look at it in when it used to live here. Oh, okay, fine. Thanks, get. Okay, well, I suppose that won't work. Okay, I'll just make up a commit message then, like a normal person. Yeah, well, I mean, I guess this unfold. Yeah, maybe I'll just say unfold BR table instruction. That's close enough. Why don't I follow my own advice and do this with a tap? Indexes. It's not very helpful, is it? Because I just need it in a local variable straight away, so that's not the same kind of thing. If I extracted this into a helper, that's exactly what I would do, but here it's just going to be ceremony I don't need. So let me justify that. Well, let's make this opcode. Well, no, it is the whole instruction, isn't it? It's just made of opcodes. It's just made of the opcode and all the arguments. A BR table instruction can be followed by... Well, it has to be followed by at least one. Let's say is followed by... Yeah, this isn't quite right, is it? So this should actually be... This is mandatory. So REST has to look like this. And then indexes can start with that index in it. Let me just check that that still works, but I think that's more honest. Yeah. So there has to be at least one. And then there's all these optional ones. Is followed by 0 or more is followed by 0 or more target labels, and a mandatory default label. That's not very good. i.e. one or more labels. We need to keep reading atoms until, we need to keep reading atoms until we find one that isn't either a numeric index or an ID. Let's be more explicit. The BR table instruction is unusual in that it doesn't have a fixed static arity. It's followed by 0 or more target labels and a mandatory default label. We therefore need to keep reading atoms until we find one that is neither a numeric index nor an ID. Okay. Nightmare. All right. Now we've got to support parsing BR table. So the AST is going to need BR table, struct new. So semantically, this was like target indexes and default index or something. Yeah. I think that's right. Let me just look at it's in my history. Sorry, stream. Oh, come on. Such a terrible experience reading this document with MathJax in it. BR table, can I? Yeah, okay. Miraculously, it found that even though it didn't highlight it. Okay, so I can actually link to it directly. So all of these labels execute, default. Maybe the explanation in structure was a bit more friendly. Control instructions. Yeah, that might be slightly more friendly. Anyway, label vector that's immediate or a default target. Yeah. I mean, maybe these should be called targets. Targets and default target. But whatever, I'm just going to leave it like that. Okay, so... Oh, that's the wrong file. Okay. So where does BRIF get taken care of? Right. Well, I'm just going to have to do the same thing again. So this is why I've got this to do about unfold and parse together so that the knowledge of the staticity of each instruction only lives in one place. So, I mean, this is the pathological, this is taking it to a pathological extreme, which is that this instruction doesn't even really have a static arity. It's sort of completely dynamic in the contents of the S expression. And so I've just got to reproduce that logic here. It'll be slightly different because this destructively consumes, this is not sustainable in the long term, the fact that I'm having to reproduce all of the same logic down here. But for now, as ever, I'm just going to power through and try and get it working. So this is going to say, I mean, this is really messy because it's the last one that's mandatory, not the first one. But I think I'm going to say, okay, let me comment all this out. But something like this, like this is going to say read through this regular expression into the index. It's got to be at least one of those. So that's going to be the first one. Again, we're sort of initializing it like that. And then this loop becomes while peak in that regular expression so that's it. And again, there's some redundancy here because I'm forcing it through that match, even though we know that it must. But I'm keeping it consistent with this thing here. So each time we read, we're asserting. I mean, maybe read should take a regular expression, because that's what we do in the S expression parser. This takes a pattern. And then I believe it complains if it doesn't, try match or complain. So maybe that's something to do here. Add regular expression parameter. This is like optional. Regular expression parameter to read. Where we're just asserting that some pattern matches the next atom. Some of the cases we're doing this where we actually want match data, but in this case we don't care. We just want an assertion. I mean, it wouldn't be so bad if that, if it returned match data, but anyway, that's too complicated. It's just a to-do. So we read all of those through, but then we need to split that array in a different way. We have to say indexes goes into target indexes, and then default index that's like the last one. So this is very unusual, but we're doing it. And then I think we can just do BR table new target indexes default index. How does this? I'm just looking at what I've done stylistically elsewhere. Not very much is the answer. Yeah, I guess, I'm just in terms of like having a new line. I guess this is kind of that is the slurp in all the indexes. You could imagine extracting that into a function, and then the result is the target indexes and the default index, basically. Okay, so right. So now the problem has gone up to the next level, which is what we want, which is that it successfully parsed, well, it's just left these as strings, right? Because again, we can't look them up in the identifier context. So at the moment, the interpreter is going to have to interpret those, which also is a thing that pains me, but I'm just going to have to live with that for now, for the sake of keeping things focused. Again, I'm looking for commit message. Parse BR table instruction. Oh. So actually, I sort of wanted this to be part of this commit, didn't I? Because I've kind of changed my mind about yes. It has to be one or more. So that's what that's doing. Maybe it's nicer if I tighten that up, because then that matches what I do in the next commit. Yeah, a load of messy munging to get those indexes. Yeah, this is where you really want like a do while loop, which you can. There is a way of doing that in Ruby, but it's somewhat frowned upon, so I think I'll leave that for now. I'll take theirs, and then I'll just fix up this. Yeah. Okay, that is what I wanted. And now, finally, I think this is going to be the last thing that I do in this stream, not in my life, one hopes. Oh, look, evaluate instruction is just one big old switch. How refreshing. In BR table, target indexes, default index. So I believe the semantics are /is stack.pop1 is, I mean, what's the right name for this? It's like the index. I'll just call it index. If index less than target indexes dot length. So what we're doing here is target index equals, if this is in range, then it's target indexes slice index. I mean, index is a really bad name here. maybe I'll call this table index. If table index is less than target indexes, then we're indexing into the table, else default index. How does BRF work? Because that's basically what we want to do. Oh, we're calling it tag. Yes. Okay. So this is I don't know why I'm telling you this. That's just copied and pasted from BRF. Okay, fine. We'll just call this index. And then tag is equal to case index in string throw tag branch. Uncaught throw. Okay, so I mean that's sort of doing what it's supposed to. It is throwing, but it's throwing a string. Hold on. Is there something in the AST parser where I turn things into integers? Oh, yes, there is. Gosh darn it. Okay, all right. Well, let's at least attempt to do that here. Okay, well, it needs to happen before. Oh, what am I doing? It needs to happen before this. All of these indexes need to be indexes equals indexes.map do index. If index starts with $, then leave it alone, otherwise integerify it. So actually we do a tiny bit of parsing on these. So they're either a string or an integer, because that's what this conditional is designed to pick up. It symbolizes strings for object identity comparison reasons. So this is just Ruby internal stuff. It's not really part of the AST representation. That's fine. But obviously we wouldn't need to do that if we'd if we'd correctly looked these IDs up in the identifier context, because they would already be numbers, but this is just transitional, so that's fine. So I think maybe this is going to work. Yes, it has worked. Fantastic. However, I need to, well, it's just AST parser, I think. Just need to amend that so that it's doing the index massaging. Hold on, I could just do that like here. That's not incredibly beautiful, is it? But in fact, it's so unbeautiful that I'm just going to leave it as it was. Oh, what did I used to say back when I was implementing instructions? That's not how... I'm not in Vim. Implement the drop instruction. Implement the... Yeah, I guess BR table. Well, maybe I can say this now. Because it's an AST instruction, not a... No, I think maybe it's nicer to keep naming these after the concrete syntax. And maybe I can... Maybe that's when I link to the semantics here. This instruction looks up uses its operand as an index into the variable length So it uses its operand as an index into its variable length list of immediate arguments. If the index is in range, it uses that immediate argument as a branch target. If not, it uses the default index. Is there really... Oh, it just links to control instructions. Okay, so if I want to link to it, I really do have to have this horrendous MathJax URL. Okay, fine. Well, that's probably enough, isn't it? It's obviously a little disappointing that I'm continuing to bash my head against. Like now, I don't have support for call indirect. So even though as BR table first and as BR table last have both started passing, now this call indirect. I mean, this seems to be testing how if interacts with other instructions. So this is sort of putting it inside a call indirect. And this is using it with store, which fortunately I have implemented. But now there's memory.grow. I've implemented drop. There's branch here. Local.set I've done. Local.t I've done. Globals. So this is, unfortunately, this is taking me on a magical mystery tour of all of the other features of WebAssembly, just so that we can check how if interacts with them. So I think I probably need to pop this one off the stack for now, temporarily, because it's going to be too much. There's like too much other stuff to implement here, but I'll think about that next time. So in my general to-dos, I'll say next, pop if.last off the pending stack, because it looks like it's exercising lots of other WebAssembly instructions, which is going to be too painful to get through in one go. Find a different test, since this one was picked arbitrarily. That constitutes slightly lower hanging fruit. Okay. All right. So that's my That's my note for next time. Let's do the thing and hope that GitHub is working this time. So I'll just let this run through. I'm pretty sure these tests have got significantly slower since I finished my AST parser, so that's not a great sign, but not completely unexpected given what I said, that I've made it, for the sake of keeping the code neat, I've made it pass over the entire expression at once, right at the beginning, just to find the end of it, descending recursively through all of the nested blocks and loops and stuff diligently to make sure that it's possible to reach the end of the string before it even starts parsing it, to reach the end of the S expression before it even begins parsing it, which is unnecessary. So I need to think about some performance optimizations there because it is becoming too slow. But this is failing in the correct way. Pending test failed successfully. I will push this. I will hope that the GitHub gods are smiling on me, or the GitHub Actions gods at least. Yes. Here we. Yes, okay. It is getting a bit slow. All right. Nice. What's happened to the run time? Can we see that? Oh, actually, it's not significant, is it? 37 seconds. This is 39 seconds, up from 36. So actually, I mean, yeah, maybe I'm just imagining that. I'll take some measurements and find out whether I'm imagining it. But the point is, the tests are passing, which is all we really need to know. Whew. All right. Well, I think that's it, isn't it? That'll do for tonight. So I will say bye. Like I always say, I really appreciate whoever you are out there. I don't think anyone's watching this live. I think I'm literally just talking to myself at this real-time moment. I don't think anyone is listening to me, but this video is going to end up on YouTube. There is a non-zero probability that one day a human being will hear me say this. So I just wanted to say I really, really appreciate you slogging through this for whatever reason you choose to do so. I'm very grateful for your attention. I feel like I always say this. That wasn't a particularly interesting one, was it? We just slogged through a bunch of refactoring and then engaged with some of the fiddly semantics of a couple of WebAssembly instructions, but that's what it's all about, I suppose. So yeah, thank you for watching. I'll carry on the next one. I'm going to keep going until something happens. So yeah, I'll see you next time. Bye bye.